What is Bug Bounty? Bug Bounty is a safe, legal, and accessible way to hack companies and earn money or recognition, while also making the internet a little bit safer. Companies encourage ethical hackers and their power users to find weaknesses on their systems before malicious actors do. A responsible disclosure report can earn you cash, swag, or public recognition. Why do companies run these bug bounty programs? Mostly because they are cost-effective, and it gives them 24/7 coverage. Imagine thousands of researchers that continuously watch their public internet assets, yet they pay only when a valid bug is reported. No bugs, no payouts. There are two types of bug bounty programs. VDP, Vulnerability Disclosure Program. Companies like NASA or Red Bull offer recognition instead of cash. NASA lists you in the Hall of Fame with a nice certificate, and Red Bull sends you cans. PvP, which is the most popular one, is a bug bounty program. In those, the reward is actual money. It starts from $100 and could go to well over $10,000 for a critical submission. Bigger impact, the bigger the bounty. Bug bounty is open to everyone. You find a bug, submit a concise report, and get rewarded for it. Whether financially, career-wise, or just for the bragging rights, so you could say, I hacked this company. Before you report your first bug, it's important to know the key personas you'll meet in your bug bounty journey. First, the company. The company invites you to test their assets. They are the client. They set the testing scope and the bounty payouts. Then, we have the platform, like HackerOne or Bugcrowd. They handle communication and payments to your bank account. You'll also interact with the triage team. They validate your reports. Sometimes they are run by the platform and sometimes by the program itself. And finally, the hacker. That's you. Payouts are based on severity, ranging between low, medium, high or critical. In general, reports are considered private. Sharing a report publicly only happens through coordinated disclosure, and only after the issue is fixed. And remember, not every decision will go your way. Sometimes reports will be closed as duplicates or informational, even if you don't think they are. So we must stay professional. Your reputation matters more than winning a single argument. Welcome to the terminal. In bug bounty hunting, the terminal screen is your single most important tool. It's where all the real action happens. My goal in this chapter is to show you that the terminal is your gateway to becoming a much more effective and faster bug bounty hunter. The reason we use it is simple. All of the best, most powerful security tools are built to run there. They don't have fancy buttons or graphics because they're designed for speed and power. The terminal also unlocks automation. It allows you to chain tools together, creating workflows that can test thousands of assets automatically at the same time. This is how you scale your hunting efforts. We will go through the basic commands that you'll use every single day, setting up your environment properly. Installing your first set of essential bug bounty tools together. The goal is to get you comfortable enough to run the tools we are going to use throughout this course over the terminal. Once you have these basics down, a whole new world of powerful tools will be open to you. To find bugs in web applications, you first have to understand how they work. Before we even open a tool, we need to cover the fundamental building blocks of the modern web. In this section, we are going to focus on the most important concepts. We look at the journey of a single web request, from the moment you type a URL to how your browser communicates with a server using HTTP. We'll explore how websites use cookies and sessions to remember who you are. We'll also break down the important difference between the code that runs in your browser, the front end, and the logic that runs on the server, the backend, and how they use APIs to transfer data. In the text below, we are going to dive deep into each of these components. We'll also break down URLs, HTTP headers, common status codes, and much more. Once you understand how a web application works, you'll be ready to find the places where it might break. Okay, you now understand how web applications are supposed to work. Now we get to the fun part, learning how to break them. In this chapter, we are going to talk about the actual bugs, the common, repeatable mistakes that you will find everywhere, from startups to the biggest companies in the world. When it comes to finding these bugs, there are two main approaches. The first is the automated approach, where we use tools to scan for low-hanging fruit, like misconfigurations and non-vulnerabilities. The second is the manual approach, the detective work. This is where you log in an application, intercept the traffic, and really dig into the logic of how it functions. The best bug bounty hunters master both. So, what are these common bugs? In the text below, we are going to cover the stuff that gets resolved. You learn about IDOR, where simply changing a number in the URL can give you access to another user account. We'll cover subdomain takeovers, where you can take control of another company website. And we'll look at finding secrets, like passwords and API keys, that developers accidentally leave in public code. People often ask me for the secret to becoming a top bug bounty hunter. They expect me to name a specific tool or a complex technique. But my answer usually surprises them, because a massive contributor to my own success wasn't a tool, it was people. One of the best things I did, especially early on, was to start collaborating with other hunters. I realized that I couldn't be an expert in everything, so I connected with researchers who had different skills so we could complement each other. We started a small Slack community just for us, where we could share tips, look at targets together, and celebrate each other's wins. That small group became a huge force multiplier for my own journey. This chapter is about leveraging that power. In the text below, we'll cover all the practical ways to do this. From following the right people on X and learning from bug bounty write-ups, so you could find your own group of people to collaborate with and supercharge your bug bounty journey. That's the real secret. You don't have to do it alone. Some are amazing at automation, others at finding deep logical flows. When you combine those skills, you can achieve things that are impossible on your own. This chapter is about leveraging that power. In the text below, we'll cover all the practical ways to do this. From following the right people on X and learning from bug bounty write-ups, so you could find your own group of people to collaborate with and supercharge your bug bounty journey. If you search for hacking tools online, you'll find thousands of them. It can be overwhelming. The good news is you don't need thousands. To be effective, you only need a handful of powerful tools that work well together. I want you to think about your tools in three main categories. First is your web proxy. Think of this as your X-ray vision for the internet. It sits between your browser and the target and lets you see and even change every single request. The industry standard here are tools like Burp Suite or Kaido. Next are your Reconnaissance tools. These are your scouts. Their job is to map out a target's entire attack surface, finding every subdomain and live website so you know where to focus your attention. For this, we'll use tools like Subfinder and HTTPX. Finally, you have your fuzzing tools. These are like your digital lockpicks. Try thousands of combinations a second to discover hidden pages, secret directories, and forgotten admin panels. Throughout this course, we are going to put them to work, showing you how this exact workflow was used in my own real-world hacking stories to find critical vulnerabilities and earn major payouts. In the text below, you'll find the exact commands to install and configure your hacking machine. Let's talk about the topic that's changing every industry, including ours, artificial intelligence. There's a lot of hype and FUD out there, with some people thinking AI will replace bug bounty hunters. I don't see it that way. A lot of our current automation is very deterministic, and AI is not necessarily a substitute for it. Where I see AI making a massive impact is as a powerful assistant that augments our own efforts, especially in the most complex and time-consuming parts of manual hacking. Think of it as a human-in-the-loop approach. We are still the pilots, but now we have an incredibly smart co-pilot to help us navigate. In the text that follows this video, we are going to explore this practical approach. I'll show you the best ways to utilize AI, especially with post-authentication testing, dealing with massive JavaScript files, and to strategize new attack vectors when you're feeling stuck. Okay, we've just covered a huge amount of foundational knowledge, from the terminal and web basics to the most common vulnerabilities. That's a lot of new information to absorb. This is the perfect time to note that no one expects you to have all of this memorized. I look things up every single day. What matters isn't perfect memory, it's understanding the core concepts and knowing where to find the right details when you are in the middle of a hunt. That's why we've built a comprehensive cheat sheet covering everything we've discussed in this foundation section. It's your complete reference guide designed to be used during active bug bounty hunting. We hope you'll find it useful. Hey everyone, super excited to welcome you all to our Reconnaissance chapter in the Bug Bounty Masterclass. This is one of my most favorite subjects, and here I really want to take you into the process of taking a company name or an actual root domain of a company like google.com and find its entire attack surface over the internet when you're doing bug bounty hunting or pen test engagements. So let's get started with some slides that I made for this chapter. So when I'm saying reconnaissance, what I actually mean is the process of discovering all publicly accessible assets of a given company. So your input would be a company name or a domain, and the output would be whatever is publicly facing in their attack surface from this company. So for this section, we will use our own CTF as a target, which is bugbountymasterclass.com. So you can follow along with that, or from any program you'd like in the public HackerOne activity that you can just select and follow the scope. Or there are some other great programs that are not on HackerOne or Bugcrowd, like Apple, Meta, or Google, that have the scope defined, and you can follow along with this chapter of discovering assets based on their scope, program scope. So when we're looking at a target, let's do some terminology before we start. So we have acme.io, for example, in this case. So when I reference a top-level domain, what I mean is the IO, the ending of the domain. It could be .com, .security, .ai. So in this case, it's IO. When I say root domain, I will mean the main domain with the TLD, the top-level domain, and the one step forward, one step up. So in this case, it's acme.io, google.com, meta.com, all of these other examples. A subdomain is when we discover more public assets under the root domain. So it could be app.acme.io, admin.dev.acme.io. So basically, subdomains is more public assets that they all reside under the same root domain in the hierarchy, I would say. And finally, we have also a subject which is called a company name. So let's say we are Acme.io, so we have Acme Inc. This is our company name. Could be Google, Meta, Apple, all the actual company names that register the domains to the internet. So the goal of this lesson is for you to learn the process of discovering all the publicly accessible assets of a given company. So I will give you a root domain, and you will find all the subdomains as first step, then all the other root domains. There are a few methods to do that, and the subdomains of their other root domains. So it might be a little confusing now. There's also full text in the course chapter that you can follow, but hopefully it will be more clear very soon. So how does DNS reconnaissance look like in a high-level overview? So we have bugbountymasterclass.com. This is our course website, and I want to find all the subdomains, all the application it's hosting in other domains than the root domain of the application. So there is a passive process, which is basically just querying public resources and asking them, do you know anything, any domain about bugbountymasterclass.com? Did anyone ever crawl my website? Did Google index it? Are you aware of more applications that I'm hosting to the public internet? This is the passive part. And the active part is where I'm actually trying to guess more subdomains by my own. Does admin.bugbountymasterclass.com exist? I'm trying to actively brute force and try to find more potential subdomains to my application. So then we don't want to stop here. We want to find more root domains for our company. So that, let's say I'm bugbountymasterclass.com and I have a company name, and then I did some acquisitions. I bought acme.io, I bought example.com, I bought agile.com.
So then by myself doing more acquisitions, I'm adding more root domains to my attack surface. And then I could also try to attack those. I could also try to find their own subdomains because we want to find all the publicly facing applications on the public internet. So I can use the company name or acquisitions when it's in scope to find more assets to hack. We also touch about who is, and there's also SSL certificates where we use the company organization name to find more root domains that we can check. For example, google.com, they also have ai.google. They also have an own TLD. Like also Amazon has their own top level domain. So like everything.amazon, everything.google. So it brings you more attack surface when it's in scope to the public programs. So I like to use a tool called Subfinder, which basically how it helps you to do reconnaissance in an easier way. It just encapsulates a lot of public services over there. Some of them are paid, some of them are free. And it just sends requests to all of them at the same time, instead of you browsing to each web page. And then it gives you the result of all the subdomains that the public internet knows based on the API keys or the public services that you used. So for example, instead of me going into certificate.sh, which is a website which checks every time someone registers a new website to the internet with an SSL certificate, then it adds it to their database, public database. So instead of me going there or going to Shodan and trying to find more subdomains for my own website, bugbountymasterclass.com, I will just use this tool, Subfinder, and it will do it for me because it just sends an API request to all of the services and gives you the results to your terminal in a very easy way. So this is the command I like to run first. Just subfinder -d, the root domain we want to check for more subdomains, and then I save it into a file called passivesubdomains.txt. And you can see here some results that it already found when I use this command. Now you can also use the verbose flag, which is -v. Then it will show you the sources that it found at subdomains. If you want to dive deeper, if you want to know which sources know, if you want to know what sources you want to configure your API key inside them. So this shows you which source was like responsible for which subdomain. And it can also show you if some services are not working if you don't have an API key. So you can try to run the command also with a -v flag. So now what I want to do, I want to take all the results that I did and save them to a file, which is what I did in the earlier step. We save them all in the file in our file system, which is called passivesubdomains.txt. So now we can just read the content there and just see the results in a very easy way. And we can do more stuff with it later on, check, for example, what assets are publicly facing, because now we just have a list of names of subdomains. So out of the subdomains we discovered, we need to check which ones are actually resolving. So this is like what Google AI says about the process of resolving subdomains, but in a simple words, is the process of taking this human readable text like www.example.com and turning it into the IP or the underlying resource behind them to know if they actually have a machine, if they actually have a server, if the host is actually alive and serving content. So for that, there is some like built-in commands in Unix, like in Mac, if you're using Mac or Ubuntu and so on, or Linux. So there is the dig command. And using the dig command, I'm trying to find the subdomain, for example, nagli.bugbountymasterclass.com, and it doesn't exist. So you can see there is no record here, and the status is NX domain. It means there is no record behind you. If I'm trying to check a domain that actually exists, like www.bugbountymasterclass.com, then you can see it actually says no error, and it finds IP addresses behind it. Here I'm using Cloudflare outside my to serve my website. So those are Cloudflare IPs for this example. So DNS probing, when I'm saying that, it's the second step after getting a list of subdomains. Now we want to see which ones actually have some resources behind them, so they're actually alive. Because if we have millions of subdomains, we don't want to check all of them if they are publicly facing, if they don't have even a resource behind them. And doing DNS probing is easier, and it's more lightweight and faster than doing HTTP probing on every asset that you have. So I like to use a tool called PureDNS. You can check it on GitHub. It makes it very easy. Just instead of sending dig like every time to every single domain, I can just give it my file, run the command PureDNS resolve, save it to a file which will store all my resolved domains, and then it does it by its own. It takes the 19 records I found on my first step, and then it returns to you that 12 of them are actually publicly facing. It's also doing some more advanced technique, which is wildcard filtering. I'm not going to go into that in this chapter, but you can read about it. So it actually dedupes some of the applications. If you're having a major SaaS company and they have a lot of the same applications under the same subdomain, then it will dedupe them. It can be very helpful sometimes to dedupe hundreds of thousands of subdomains into actual one application. Because if it's the same application, there is no reason to test it again and again if it's actually the same content and resources. So now we have a file which is called the result file, and this is the file of a list of subdomains that we found for a single root domain, which have a resource behind them, so they are potentially publicly facing. This is like the core concept of me having a resolved file. And now this topic is a little bit more advanced. You don't need to use active DNS discovery at all times. A lot of the times, passive subdomains discovery is also great and brings you very good results. But just for the sake of the course, active DNS discovery is the process of DNS fuzzing, guessing, or DNS permutations, which we'll touch upon now. So up until now, we relied on public sources to discover potential DNS assets. However, that is not enough because there might be additional subdomains hiding in plain sight, because the internet only knows what it knows, but if someone spin up a new service like a few minutes ago, then the internet doesn't know about it yet, but we can still try to find it if it has a common name. So for this process, I'm also using a pure DNS and also a word list. So you can download a word list. I put a few examples in the previous chapters for word lists. It could be million subdomain word list, 10 million subdomains in a word list. Those word lists will have the words like admin, backup, internal, staging, QA, some common words that developers spin up subdomains for. And then the process is simply asking, hey, does admin.acme.io exist? Does backup.acme.io exist? And so on. So it's just us trying to find more and more and more subdomains, like not relying on public sources. And this is the simple command. Here I'm running it pure DNS brute force on a very small DNS list. It's not very small. It's almost 400,000 words, but it's considered small because it's very fast. Then I'm putting the root domain. This is our CTF root domain. And here it shows you it's running pretty fast on my server, like 25,000 queries per second. So this is very quick. And then it brings to you back if it found any additional subdomain that I didn't know about before. For this concept, it's not only enough to do it on the main domain. If you have a huge application that you see in their naming conventions, that they have a subdomain, for example, airlines.bugbountymasterclass.com, and then you see that it has more subdomains to it, like a children's subdomain, like test.airlines.bugbountymasterclass.com, then it might be useful to try brute force this own subdomain. Because I won't have in my word list test.admin.airlines. But if I'm trying airlines anyway, then I might find test under it. So you don't have test.airlines, but you can find the word test if you brute force airlines.bugbountymasterclass.com. So this is also a useful trick. If you see a convention of a subdomain that has many children subdomains, you can try and brute force that own subdomain to try and find more juice there or more public attack surface to attack later on. So this is about DNS brute forcing. You also have it in text. You don't need to do it every time, but it's very nice technique. And to close it up, the active DNS fuzzing, we have DNS permutations. It assists in discovering unique, non-trivial subdomains based on existing data. So here, the concept is we take the subdomains we already found. Then we take a word list. Again, this could be a little smaller, not need 400,000 words, could be 10,000, 5,000 words, admin, backup, and so on. Then I will use a tool called AlterX and pure DNS again. So what does AlterX tool actually does? If I know backups.acme.io exist, it asks, does admin-backups.acme.io exist? It asks if stage-backups. It asks if backups-internal.acme.io exist. It creates a lot of permutations based on the domains we already know exist. So traditional brute forcing won't help here. It tries to do conventions based on the domains we already know, and then we can find more interesting data that public sources might not be aware of. So running this command is also very easy. I just checking the content of the file that I have all the passive subdomains. Then I can use the AlterX command, and this is how it looks like. It just tries to add more unique combinations. Service-logistics, corp-content, deep leak-monitor, just a lot more combinations that we can try and check if there's more assets resolved. So it's all the same concept. We just want to find as many subdomains as we can. So we want all of this content from the passive and from the active process to be saved in one singular file called resolve. And in this file, we will have a list of subdomains that will have underlying resources under them. So I recommend starting with public sources like Subfinder, and then you can, if you want to feel more advanced or you're hacking on the program that accepts wildcard domain, they have a lot of assets, you can also invest some time in going very deep in the active subdomain reconnaissance. And now for another concept. So until now, we try to discover subdomains, but we can also try to discover more root domains to hack. So the most popular technique here is just to look for acquisitions. You can look on Crunchbase, Google, X, wherever company announces acquisitions, you can just look for them. So if I'm taking Google's public bug bounty program, so you can see that they say any Google owns or Alphabet subsidiary is in scope, specifically those. So you see YouTube, which is an acquisition, DeepMind, which is an acquisition, Waymo, which is a service of Google. So it's more services that could have more attack surface, and you want to find their subdomains as well when you're doing reconnaissance. So the concept here is if your program accepts everything or all the subsidiaries, you can use Crunchbase or Google, and then you want to do the same process for every root domain that you discover. You find the subdomains, you resolve them, and you add them all together to a mega resolved file, which you will use later to see what is publicly facing. The same concept is also applicable to the WHOIS protocol. WHOIS is basically a public directory that stores contact and technical information about who registered the domain to the internet. And there is some method which is called reverse WHOIS. So I will give you the company name or register the domain, and these resources, public databases, or like any public servers that store this WHOIS data, basically they scan the entire internet. They're doing the WHOIS command, and then they save all the data in a database. And then you can ask it, hey, do you know what other domains Bug Bounty Masterclass have? Do you know what other domains Google registered? So this is this technique of reverse WHOIS lookup. So if I'm checking my own website that we did for the CTF, so it's actually redacted. Companies can also redact the actual WHOIS information. If you can check Google, for example, it just gives you the public name, Google LLC. Then you can check if Google LLC has more root domains, if they accept it in scope, so you can expand your attack surface. So there is WHOIS. I like to use a tool called Hooksy. It's a paid tool, but you can do queries for free also in their website. And Shodan, it's good for certificates. Also, when a company registers a certificate to the internet, SSL certificate, it means they allow the website to be browsed with port 443. A lot of the times, they also put their organization name inside the certificate. So you can also check on Shodan, giving a company name as input, and it will give you more root domains that this company actually have. So just to give you an example of what I mean, so let's say Google AI, they have a root domain which is called ai.google. So it's not google.com, it's actually another root domain, and it could be more attack surface to find subdomains on if it's in scope, and to try to find for more bugs. So this is the concept of like expanding also to more root domains, not only subdomains. So we will take all the root domains, acme.io, acme-stg.io, acme-dev.io. We will do subdomain reconnaissance for those. We will resolve and again put it all in our very big resolve file, which I will show you now how we will use it to check what is publicly facing. So the concept of public exposure should be pretty straightforward, and I will go with you with the tool that I like to use. So public exposure probing. So the previous steps helped us really assemble a comprehensive list of domains that are 100% attributed to our target company. And now we want to assess public exposure, so not all the discovered assets are really publicly facing. So I divide it to two steps. First, web exposure, usually ports 80, 443, or some self-hosted applications on unusual ports like 8080, 9000. And network exposure is for more network-based services like Postgres databases, SSH, FTP, Redis. So this is like more network hacking, and the first one is more for web services that are publicly facing. I like to use a tool called HTTPX, and using this tool, it allows you to probe all result subdomains for standard web exposure and extract relevant data for your automation in the future, or to know where to focus on first. You can get the technologies and the metadata of every website without actually needing to navigate to it with your browser every time. So here is an example on our course domain, bugbountymasterclass.com. I'm taking the big result file, I'm running the HTTPX command, and I'm telling it, I want to see the title of every page, I want to see the status code, I want to know if it redirects me to another page, I want to know the IP, I want to know if it points as a CNAME to another service, and I want to know the technology that you can detect and save it all into a file called metadata. And then you can see some of the results. You can see the status codes, titles, IPs, technologies, and so on. So this brings you, like, if you have a lot of domains that you want to check and you can't really navigate to each one of them, this makes it way easier to know what is publicly facing, and it can give you metadata so it can detect technologies for you So if there's certain misconfigurations that only work on a specific technology, you can go to these websites right away. So I like to use the metadata file that we save to do extra queries if we want, let's say, to focus on all the public servers that return 200 status code. It means it returns success and there is actual content that we can try to probe and find bugs on. You can just do grep 200 and just try to hack and go on these websites and see if there's any misconfigurations or any forgotten services with very easy bugs. Sometimes we have status code 404 or 403. What it means is that on the main page, we try to check the main root path of the page. It either doesn't exist or it's forbidden, but it doesn't mean that if I would try admin/admin, for example, that it wouldn't work. You will also see an example for that in one of the real-world hacks in the next chapters, but these indications are only for the root path of the domain. But if you could try other paths like add/admin/backup, it might show you actual content. So it's also nice to sometimes look at these domains and try to guess more passes for the domain, like /admin. There are some processes you can also extract screenshots if you like it more visual. If you have tens of thousands of domains, you can try to vibe code a screenshots viewer for yourself, so you can see if someone spots your eye and, hey, okay, this apps look very weird, I want to hack it. For the network exposure phase, I like to use a tool called Nabu. There's also tools like Nmap, Mascan. They all do basically the same. It just tries to show you unusual ports. So in this case, I took one of the domains that we have in Bug Bounty Masterclass and I wanted to scan more ports. You can scan the top 100 ports, top 1000 ports, all ports, or just any port that you'd like. So in this case, I wanted to also scan two unusual ports, 8123 and port 9000, and I see that it actually returned results and that the ports are actually publicly facing and open. So here I would want to put it again in the HTTPX sources and get the metadata of the services to know if they're really publicly facing and they really host web server that I can access myself. Important note here, sometimes WAF services show you all the ports open all the time. So you really need to use the duplication and check that you're not like getting all ports are open for all your assets and just waste a lot of time doing HTTP probing. You now know how to discover all publicly accessible assets of a given company. This is the initial step of discovering impactful vulnerabilities and misconfigurations, and we will also see it later in the course. And some bonus chapter with Cloud Code. I mean, I just set up Cloud Code on my server. I asked it, hey, can you look for subdomains on bugbountymasterclass.com and check what assets are publicly facing? And it did it for me pretty easily. It sent a request to certificate.sh. It saw that I have Subfinder on my machine. Then it used Subfinder. It took this process that I showed you right now. And then it found several subdomains. And it tried to probe for what is publicly facing, exactly like I did with HTTPX. So this is nice to see the process. Then it also gave me a very nice summary of what subdomains are active, the table, the title, the tech stack, and so on. It can also give you insights. So I wouldn't take those too deep to the heart. Maybe it's hallucinating and stuff, but this is very nice way to just, you can just send your AI to do some reconnaissance for you. But I always recommend deterministic scripts if you already know the process, so you wouldn't count on AI to maybe make mistakes. But it's also a nice example of the advancements of AI now in the field. What are the next steps? So you choose a program, you can experiment a little bit with Reconnaissance, either public programs on HackerOne, self-hosted applications, or our own CTF in the next chapters. Then you can use a tool called Nuclei to scan for common vulnerabilities and misconfigurations. We will see examples for that. You can look for historical endpoints, like on a Wayback Machine, and then find some maybe endpoints that were, when someone developed the application, there was a /dev folder open, then it was closed, but it was already indexed in the internet. And then when you do /dev, it shows you all the websites open, all the source code. So this helps you find more pass endpoints like /admin/dev that might be open and vulnerable to several attacks. This also relates to you can do pass fuzzing now. You can try to guess more endpoints, not more subdomains. I like to use a tool called FFUF for that. And OSINT queries like Google docking or GitHub docking. You can use some of the subdomains that you found to try to see if Google have indexed some interesting data on them with the crawlers, or GitHub, maybe some developer put some content on a subdomain over GitHub. So you can use also the data there to look for secrets or forgotten assets that are publicly facing. So thank you all. The next chapter will be for web proxies, which is how to hack websites manually. And in the final chapter, we will see some practical examples that we put to the test using the techniques in this Reconnaissance chapter. So thank you, everyone, and see you in the next one. Okay, so hey everyone, I'm super excited to kick off our web proxies and manual hacking section in our Bug Bounty Masterclass. with no other than Justin Reinorater. Justin is one of the world's best bug bounty hunters who won plenty of live hacking events, earned over $1 million in bounties, and most importantly, he helped hundreds of people go from zero to scoring their first bounty payouts, and you are a very good friend of mine. So thank you for joining us in our course, and I'm really looking forward to this session. And yeah, let's see what you prepared for us, and very much looking forward to it now.
Awesome, man. Yeah, dude, we've crushed it together at the live hacking events. It's been a blast, and thanks for the opportunity, dude. I am really passionate about teaching people about bug bounty and helping them get their first bounty. So hopefully today, using Kaido, we'll accomplish those. So let's jump right into it. This presentation is efficient web hacking with Kaido. I've given a variant of this from time to time, but we've jazzed it up a little extra today with Wiz, and I think we've got some really good content in store. Like Nagli said, like my boy Nagli said, I'm Justin. I'm an advisor at Kaido, so I work with the Kaido team. I'm also a professional live hacking event participant, is kind of how I like to put it, but I'm a full-time bug bounty hunter, and use that to supplement my life. So I've been doing this for about 5 years at this point, full-time, and it's been a blast. So I'm hoping we can get you guys to that as well. I also run the Critical Thinking Bug Bounty podcast, which is a podcast where we talk about bug bounty weekly, in depth at a very technical level. We try to aim it a little bit more towards intermediate to advanced, but beginners, if you want to listen into it, hopefully you can get some of that good stuff by osmosis. All right, let's jump right into the content. So the goals for today are understanding Kaido as an HTTP proxy, right? So understanding what roles HTTP proxies play in the hacker's workflow, and also get you guys on the path to finding your first bug via SimLabs, okay? So let's go ahead and jump right into the syllabus. This is exactly how we're going to do that. We're going to first talk about the architecture and how to get Kaido set up as an HTTP proxy. Then we're going to jump right into familiarizing ourselves with Kaido. We're going to talk about all of these different parts of Kaido. It's a very thorough tool. There's lots of different components to it. And I'm going to get you familiarized with all of them. Then we're going to talk about some plugins to Kaido, some first-party and third-party extensions, and then we'll sort of set you off to hack the planet on a bug bounty program. Sound good? Nagli, everything look good there?
Let's go, yep.
All right, let's do it, man. All right, part 1, understanding web proxies and Kaido setup. So first, before we get into all of this, we kind of need to understand Web Proxy 101, okay? And this is going to also be built upon how the internet works. So we've already covered that probably in previous sections, but I'll give you a quick refresher. Typically, when you're using your browser, you're going to click on a website. The packet for that is going to go through some router and networking stuff and then land on the target website, okay? That's the typical flow. Now, once you set up a web proxy like Kaido, we're going to have the browser send the HTTP request not to the router, but to Kaido. And then Kaido will forward it as necessary to the router into the website. And the purpose of that is so that we can get some introspection into the HTTP requests and responses that are powering the website that you're seeing in your browser. Okay, so your browser's seeing the rendered version. It's seeing buttons you can click and text with fonts and stuff like that. But what's powering all that on the back end is HTTP requests. And that is the juice. That's what we want to take a peek at and see if we can manipulate anything to find any vulnerabilities. Okay, so hopefully that's clear. Let's go ahead and move now to downloading Kaido if you haven't already. The link is right here. And once you got it downloaded, we'll show you how to set it up. All right, cool. So you've probably downloaded Kaido now. Let's go ahead and take a peek into how it works. So once you've opened up Kaido, you'll probably see something like the screen on the left here where you'll have instances, but you don't have an instance yet. So you got to press that new instance button, and that will allow you to create a new instance of Kaido that lives at a certain port, okay? So you provide a name up the top. You can see one of mine is like normal instance. The other one's the one that I use for recording. And then you can specify a port where that instance will listen for the proxy connections. So one of the typical ports that's used in these scenarios is port 8080. So that's what you guys can use if you're not sure what to use here. Then you press the create button and you'll be kind of moved into Kaido here. When you press connect, you may be prompted with a screen like this, where you're prompted to log into Kaido. This is how Kaido does its license management. So you'll need to log in or create an account. You could also hit continue as guest, but you're going to have limited features at that point. So what I'd recommend is hitting the create account button, going ahead and creating an account through the web portal. Very simple, standard stuff. You're going to have to do like an email verification or whatever. And then eventually you'll get this account activated checkmark. Once you've done that, you can press login again from that same screen before, and it'll initiate the login flow. You'll approve it, just press allow, and then we'll be back in the Kaido app, authorization complete, and Kaido will dump you into the Kaido interface. Now, I do want to add one little piece here. The Kaido has several options of types you can download. You can download the desktop app or the CLI. Make sure you're using whichever one fits for you. Most people are going to want to use the desktop app. All right, so that's a good bit about setup. Let's go a little bit into the architecture of Kaido, and then we'll figure out how to get your proxy configured so that your browser is sending traffic through Kaido. So this is Kaido's architecture. One thing that you need to know, I'm not going to go too deep on this section, but you do need to know one thing about Kaido, which is that there's a client-server architecture, okay? So you can connect to Kaido just using your browser. You don't need a desktop app. So if you're just running the server, then your client can just be your browser. But a lot of people choose to use the desktop app as their client. But due to this sort of client-server architecture, you also have flexibility to do stuff like this, where the server for Kaido is living on maybe your desktop PC or your server at home. And the laptop, you got your laptop and you're just connecting to the server with your front end here. And that will make the load of processing all these HTTP requests much lighter on your laptop and allow you to streamline that. If all of this doesn't make sense just yet, don't worry. It's all good. You probably won't have to think about it. But I want to tell you about it because as you grow in your hacking skills, this could be a really beneficial setup for you. Okay? And this is another configuration you can do where you host the server for Kaido in the cloud, but you connect to it from your client PC. Okay, now that we've talked a little bit about the architecture, I want to talk to you guys about dealing with HTTPS, okay? And essentially, like we talked about earlier, we need to have the data from our browser go through Kaido and then go to the target websites. But due to this security feature called HTTPS, we have to configure our certificate so that the browser sends a unencrypted version of our HTTP request to Kaido rather than the encrypted version it sends by default, which is great because it's a security feature. And to do that, we have two options, and we're only going to have to do this once, guys. So hang in there with me, okay? I know it's going to get a little heavy, but you're going to have to do this once, and then you'll be done, okay? So there's two options for this. One, you can use a proxy Chrome extension in your main browser, which I'm assuming is Chrome. The one that I use is Proxy Switchy Omega 3. I just use that because I've used it forever, and it's got some nice quick swap features. Or what you can do is use the built-in Kaido browser, which I'll show you how to use in just a moment. Okay, so those are your two options. The easiest one is using the built-in Kaido browser. So once you've opened up Kaido, you should see this button right here to open up the Kaido browser. Now, if you do that right now and you haven't selected a project yet, you're going to get an error page, just FYI. But I wanted to cover this section as a part of setup first. So if you're going to go with just using the built-in browser, just go ahead and click that guy and you're good to go. If for some reason you'd like to use your normal browser, maybe it's got your passwords in it or whatever, and you want to use that, then what you're going to have to do is install the certificate for Kaido as a trusted root certificate authority. Okay, and the way that you're going to do that is you're going to click the little person at the one icon there at the top right. You're going to click CA certificate. You're going to select your platform and get step-by-step instructions on how to install it, and you're going to click download CA certificate. And once you do that, you go through those steps. Your browser and Kaido will have a trust relationship now, and the browser knows it's okay to send your traffic to Kaido. It's not trying to hack you or anything. Okay. So if you do opt for this configuration as well, I'm not going to go too deep into this. This is the web extension that I use, and this is the configuration that I use that makes it really easy to switch your proxy on and off, and it's very smooth. So check that out. if you're going down that route. I'm not going to jump into it too much. Okay, so now we've got this setup in place where our browser is sending data. We got the setup on the right. Our browser, whether it's the built-in one or a normal browser, is sending data to Kaido. Kaido's sending it to the router, and it's going to the target website, and the data is flowing back. Okay, perfect. Now we can get into the actual hacking portion. So let's start talking about familiarizing ourselves with Kaido and web proxies. All right, hackers, let's jump into part 2, familiarizing ourselves with Kaido and web proxies, okay? All right, so the first thing you need to know about Kaido is when you've launched up, you've already logged in, you've already got your instance set up, and you're connected, you're going to be dumped into a page where you can create a project, okay? What is the purpose of a project? Well, it allows the hacker to stay organized by sorting these HTTP requests and responses, configurations, workflows, all sorts of things into different project files, okay? And one of the beautiful things about Kaido, guys, is that Kaido supports instantaneous project switching. You don't have to you don't have to close it, load up a different file, whatever. Kaido, you literally just click the little button. Here, let me show you. You click this button where number 4 is at, up at the top, and you select your project, and boom, now you're in a different project. This is super helpful for bug bounty hunters because unlike penetration testers or other people that use Kaido as well, bug bounty hunters are often switching targets because they're not stuck in one like contract or engagement, okay? So the way you create a project is you click the Create Project button. You'll see it number 1 there. You give it a project name, and you press Create, okay? So I often will create different projects for different targets. So if I'm hacking DoD, maybe I've got a DoD project. If I'm hacking Google, got that project. Got hacking Capital One, I've got that project. And then I'll jump back and forth as I'm hacking on different apps for different bug bounty programs. So go ahead and do that, and you should be good on the project section. There's not a ton there. There is some, I will say, you can sort of see it up at the top left. There is a backups portion of the project page as well, where if you ever want to like back up your project, maybe you've got it in a certain spot, or maybe you want to save it off to a different device, you can do that as well. Not super relevant to this course, so I'm not going to jump into it right now. Next up, y'all, this is where the meat happens, okay? So get your hacker pants ready because this is the meat, okay? So HTTP history is probably the place where most hackers are spending the most amount of time, okay? This portion of Kaido, which you can find on the left-hand side under the HTTP history tab, shows a flow of the HTTP requests generated by the website that's proxying through Kaido, okay? The requests made by the website are shown in a table view here and are selectable so that you can see the raw or pretty printed version of the HTTP request that correlates to. You literally use this every single time I open Kaido. So definitely you're going to want to spend some time here getting to know how to use this interface. So let's talk a little bit more about this interface. Lots going on here. You'll see at point number 1 there, we see a request that's highlighted in red. Yours may or may not have this feature. It should be shipped with your version of Kaido that highlights the top level navigations, but you may have to turn it on by going to passive workflows and turning on the top level navigation highlighter. But that number 1 right there is a page that generated an HTTP or an HTML response, and then everything after it is sub-resources from that page, okay? So you can kind of see those all listed there in a convenient table. And we can click on each one, and when we do, the response pane that you'll see at 3 and 4 are representing and showing to the hacker the raw HTTP request that comes across the wire, okay? And guys, this is not scary stuff, okay? Every time I teach new hackers about this, they look at this, they're like, oh, what's secfetch mode mean, And I'm like, guys, don't get in the weeds, just look at it like text. Look at it like text that your dumb neighbor, designed as a protocol, because that's what happened, like somebody's neighbor designed this, and it's just, made by humans like everybody else. And good chances are, if you're listening to this, you're listening to it in English, and so all of this is just written in English text, okay? So it's not too bad, guys. I promise. You'll get used to seeing it. I tell people, hey, give it 500 reps. Look at 500 different HTTP requests, and then you're going to be breezing through this like it's no problem at all, okay? So going back to the content that we've got here, If you look at number 5, you'll see that there's a pretty print, raw, or preview setting that you can select. This is a way to represent the response. Sometimes it'll be highlighted or formatted in specific ways. Sometimes you want exactly what came over the wire. That's raw. And preview will actually render the response. So it'll show you like buttons and highlighted text and that sort of thing, just in case you want to see exactly what it looks like in the browser. And if we move to number 6 here, there's a right-click menu on the request pane in HTTP history. We have lots of different options on here: copy the URL, send to replay and automate in findings, which we'll talk about later, add scope, and do various things like run convert workflows or query plugins relating to this specific request. So lots of places where you can launch other tools from here. Jumping up to number 7, you'll see the HTTPQL query bar. HTTPQL is something we're going to talk about in a bit, but it allows you to filter what you're seeing in this table, so you can focus only on what you want to focus on. And that is one of the biggest challenges you're going to face as a hacker, is out of all of these requests that get loaded up every time you open a website, which ones are the ones that are actually interesting, okay? And we're going to teach you how to do that. At number 8, you'll see an advanced button where you can add filters that are sort of off of the HTTPQL bar, which we'll talk about later. And at number 9, you've got some export functionality if you want to take all these HTTP requests and dump them to a different tool, okay? So that is sort of like the TLDR of HTTP history. Let's go ahead and jump into a lab where we use HTTP history to hack the lottery that we've got set up, okay? You can find this lab over at labs.chi.do, and the one we're going to be doing right now is the HTTP Hunt Lottery Lab. So go ahead over there, take a peek, and we'll show you how to solve it in just a sec. All right, jumping right into the lab, I'm actually going to start from the beginning so I can show you guys how to get into Kaido. So I've got my recording instance set up right here, and I'm going to go ahead and click connect. When I do, it'll drop me right into the last project where I was running. You can see right here, it's demo project, and you can see some HTTP requests coming through here. Once again, if you don't have, an external browser proxying through Kaido, then you'll want to use this button right here to launch your Kaido's integrated browser. And you should be able to see the HTTP requests load up in here once you've done that. So I'm proxying through Kaido. I'm proxying through Kaido here. And this is the lab website that we directed you to. So actually, I'll go back to this. You can see there's a bunch of labs here. We're going to do the HTTP Hunt Lottery lab. Okay, so let's go ahead and take a look. It says, try your luck. You have a 1 in 1,000 chance of winning a prize. Use Kaido's HTTP history to inspect the requests and responses and understand what's happening behind the scenes. Okay, so I'm going to try my luck. Oh, I didn't win. Oh, I didn't win. Oh, I didn't win. Bummer. Let's go ahead and see if there's something else under the hood going on. Okay, so we switch back over here to Kaido, and we can see, here's the index page. This is the first page that we requested, and we can see HTTP Hunt Lottery Game in the title, right? That's what we see up here. And as we start looking through, there's other requests that are coming through as well. We see one that's called analytics.php, and this is kind of where the decisions come into play. Like, is analytics.php something that I'm interested in currently? Do I really care about the analytics of this game? Probably not. So for right now, I'm going to kind of move along from this. The next request that we see is page content, and it looks like it's just a lot of text relating to the page. I do see some text called like claim your prize, which is interesting. I also see congratulations, you've completed the HTTP Hunt Lab, but I don't see any way to claim the prize. Oh, there is a claimprize.php. That's something that we could potentially look at. Okay, so we'll note that. We'll keep moving along. There's another request called random data that just has a bunch of random stuff in it. We're going to move along from that from now. Not what we're looking for. And then eventually what we do see, we see a couple copies of that, is we see the checklottery.php request here, okay? And so it says, hey, let's see if we've won. And it says 1 false. It shows the random number that we could have guessed, but it says, sorry, you didn't win, but it also links the claimprize.php endpoint with the token that we can use to claim the prize. Okay, so let's go ahead and try to claim the prize. We can grab this endpoint right here, claimprize.php, and we can go ahead and put this up here in the URL like this. Let's see. Okay. So the session has refreshed. What's going on here? Well, maybe does this token change every time? Look, it does with each one of these requests. It changes. So let's grab the most recent one this time and see if that actually does it. Surprising, man. Sometimes these things have a little gotcha, okay? And now we've put that up at the top. We've got the correct token to claim the prize. We click claim prize, and congratulations, you've completed the lab, okay? So and you can read a little bit more about the takeaways down at the bottom here, but the TLDR of what this should teach you is if we look in HTTP history, we inspect each of the requests as they come through. Sometimes there is more returned in the HTTP request than what is being displayed to the user on the website, okay? And guys, trust me, just this alone will land you bounties and find you vulnerabilities in websites all the time. They're everywhere. So keep your eye out. Be examining HTTP requests all the time because you're always going to see stuff like this that will pop up. Any other thoughts on that, Nagli?
Yeah, so I think like it's the first time when you do, like when you realize that when you click an enter or you have like a random lottery or something, there's actually a lot more going through, the browser and the HTTP request and the responses. So what's like in our mind, the website does something and we don't know what happened. And now we finally have the tools and the ways to really see everything in action, manipulate it maybe even later, and really get going into, okay, there's a lot more into the eye to what we see when we just interact as a normal user. That's what I take you.
Absolutely, man. Like that is the meat, right? And I think one of the biggest skills a hacker needs is looking at this representation of the website, right? Looking at the UI that you're seeing here, the rendered version, and correlating what you're seeing to what is happening in those HTTP requests, right? That is essential, a skill for a hacker, so that you can start piecing together how exactly this website is implemented from the HTTP level. All right, hope you guys learned something from this lab. Let's keep going. Next section in the presentation. All right, we just completed the HTTP Hunt Lottery lab. Let's move to the next thing, and that is a concept called HTTPQL, okay? So I know you guys have learned a little bit about HTTP already. You know that there's various verbs or methods that you can use, get, post, put, those sort of things. There's a path, there's headers, those sort of thing. And as a hacker, you're really living in this HTTP world where you're really thinking about these apps from the perspective of what these HTTP requests looks like. And sometimes you need to find HTTP requests that have specific features to them, or you say, hey, I really don't want to see HTTP requests that look like this. So we need some ability to filter or query these HTTP requests, and that is why the Kaido team built this language called HTTPQL, or HTTP query language, okay? Is to help us search and query HTTP. So it's very simple. I know that we're using big things here, like words like primitives, namespace, operator. This is a very simple thing, okay? There are 4 components. There's the namespace, which essentially is like, what thing do you want to query? There's the field, which is like, what part of the thing do you want to specify something about? There's the operator. So what are we doing to that thing? Or what are we, sort of filtering on for that thing? And then there's the value that you specify related to the thing you're looking for. So pretty simple, y'all. An example that we gave here is rec, which stands for request, right? Not too bad. .ext extension. So at the end of these URLs, sometimes we'll have like .js or .html or .php. That's the extension. And then we'll say .contains, right? C-O-N-T, contains. And then we provide a semicolon that we're going to be doing the value. And then we give a string JS, right? Which is for JavaScript. So essentially what this HTTPQL that we have here is doing is looking for requests where the extension contains JS. We're looking for JavaScript files, okay? So this is a very helpful tool and will help you look at the requests, find the requests you're looking for, and not have to look at the requests that you are not looking for. So very helpful. And going along with this, we have a lab that will show you how to use HTTPQL to be able to find the request that you're looking for. So let's go ahead and jump into that lab. It's called Too Many Requests, and you can find it on labs.chi.do. All right, y'all, let's take a look at this lab. Too Many Requests. This one right here. We hit Open Lab, and we hit Start Searching. And what's going on here? This lab is making a ton of requests. Let's read this line here. It says, this lab makes 100 requests to try to find a secret value. Use HTTPQL to find the request that contains secret value. Okay, so we're trying to find something we're trying to find a needle in a haystack, essentially here, right? We're trying to find something that is a little bit hard to find. So secret value has been enumerated. Check your proxy, see if you can find it. Now, if you want a hint, you can press the show hint button, but I'm going to walk you through it right now. So no need. Let's jump into Kaido. Oh my golly day. What is going on here? There is a ton of requests. Look at this. This website just made 100 requests. So I'm starting to look at these, and I'll just kind of explain what's my hacker eye is doing, okay? So I see everything is the same across all of these up until response time here, except for the ID. So as I'm clicking on a couple of these, right, it says error, try again. So these are not the ones with the secret value. So what I'm thinking is there's probably going to be some different message, right, in the response if there is a secret value. But as I'm looking through, we can actually expand this column right here and see that the response length is 391. All of them have the same response length, 391. So the person that designed this was a little bit trickier, right? They're all the same response length, so we can't find an outlier that way. So there's a couple things we could do. The lab told us to look for secret value, and we could search for that, or we could try to get rid of try again. So let's do what the lab told us to do, and we'll craft a query really quick. We'll say request, because we want to look in the response is where we want to look. So we're looking for secret value. So we'll do response, right? We can type just R here, or we can click and we can see the various objects. I'm actually not even going to type it. I'll just click here. So you click at the HTTP bar at the top, you see response, okay? The raw, right? The raw response that they have contains, and then they said for us in the lab to search for secret value, okay? So we can type secret value, press enter. What's going on here? We've got one response here outside of the original lab. It's ID number 77, and it says, wow, congratulations, you found the secret value. Okay, so that is how to use HTTPQL to find something specific that you're looking for in the response in a haystack of a bunch of different requests. All right, I think that's it for this lab. We'll go ahead and jump back to the presentation now. Did you actually, before we do that, Nagli, do you have anything else on that, or did I cover it all pretty good?
Yeah, I think just maybe if you have one, what is your most common use case when you do these HTTPQLs that you find yourself doing? I use them all the time, so there's a lot of things. But I mean, this response.raw is very, very useful when you're looking for something specifically. For example, like sometimes there's like a token that I need, that allow me to authenticate into something, and I'm like, all right, I wonder where are all the times that I've seen that in my HTTP history, right? Like where else could I potentially get that token from, rather than it just being like sent to my email or something like that. And so I put that token into my search, and I get the results. So it's helpful. Yep.
All right, let's get back to the pres. All right, so we'll jump back to the presentation now. All right, so we just finished the Too Many Requests lab. Let's talk about the next concept, which is filters, okay? So once you start getting the hang of HTTPQL, you're going to realize that there's a lot of things you don't want to see, and there's a lot of things that you do want to see. And sometimes it'd be nice to be able to bundle these. So that's why we built filters, okay? What this allows you to do is create HTTPQL-based sort of filter bundles to reduce clutter in HTTP history, in search, and in other places in the app. And of course, HTTPQL is the base language for all of this. Use filters all the time. They're absolutely essential to surviving in Kaido. You can find those on the left-hand side. They're in the nav menu in Kaido. So here are a couple ways that I use filters. I actually hack on Google a lot. So one of the ones that I gave as an example was that a lot of times when I'm hacking on Google, I like to focus on requests that are to the Google APIs or client6.google.com domain. Okay, that's where a lot of the meat that I know how to attack is stored. I keep calling it meat. It's just like content. It's the actual, like, because there's so much fluff, right, Nagli, in these applications. There's so many like analytics endpoints. There's so much stuff you don't want to pay attention to. And yeah, the meat of it is the stuff that actually powers the components that you're talking about, right? That you're interested in. So a lot of times for Google, those live on googleapis.com and client6.google.com. So I created a filter for that, and I use that often whenever I'm hacking on Google. I did want to walk you through, guys, through the UI here. Filters, if you click it from the left-hand side, you'll see at number 1 there, you can create a new preset. You'll have to, or if you have existing filters, you can edit them by clicking on the left-hand side there. And then at 3, 4, and 5, you'll need to fill out those fields. The name is, sort of the pretty printed name that you'll see. The alias is what you'll use in the HTTPQL bar with the preset operator. And then the expression is the actual HTTPQL that you want to run. So you can see here I did request.host, right, which is the host header. Hopefully you learned about that in the previous section. Contains googleapis.com. Okay, so I'm looking for just a request to that host. And same for request.host.contains and then client6.google.com. Easy peasy. All right, so now let's jump into a lab on how to use filters. This one is also going to use the too many requests lab. So let's go back to that one. And this time, instead of searching for secret value, we're going to create a kind of filter in HTTP history and apply it to HTTP history to remove the try again responses. Okay, so let's dive into that now. All right, y'all, we're going to do this filters lab now. Once again, we're using the too many requests lab. And so go ahead and you can access that at labs.kai.do. I'll go ahead and show you that really quick. Let me restart. I'm going to do it from this one, from the start here. All right, y'all, let's do this filters lab. Once again, we're going to use too many requests. You can find that at labs.kai.do. So we'll go ahead and go there. We'll select the too many requests lab. We open that up, and let's just go ahead and hit start searching. It's going to go ahead and start dumping out all of those HTTP requests that we don't want to see. We go in here, and we can just see them pumping through our HTTP history. Okay, so we got to figure out a way to get rid of them. The way to do that is to create a filter. So we can take a quick look over at the filters interface. One way that you can do that is by adding a new preset here and defining the new alias for this. Another way to do that is actually over here in HTTP history. You can write your query right here and then press this little save button right here. So we're going to let the request do their thing, and we'll write a query. All right. Oh my gosh, look at all these HTTP requests. So much fluff in here that we don't want to see. So let's work on getting rid of it. If we click on any of the fluff requests, we can see one of the things that they have in common is this taunting, try again, try again, try again. All right, let's get rid of it. So we can just copy whatever we don't want to have. We can go up to the HTTPQL bar here, and we can say response, raw, right? The raw response here, not contains, and paste in that value, okay? So now we don't want to see anything that says try again in that taunting voice, okay? So there we go. We've got our solution right there, 77. And we can actually save this, right, by pressing the save button right here as a filter. So we can come on in and we can say, don't tell me to try again, right? And then press create. And it will go ahead and create a filter for us. And we can see that filter applied right here if we want to. We can apply it. And we can remove this from our HTTPQL query bar here so it doesn't get bloated up. And then we can see don't tell me to try again there. All right. So that's how we solve the lab using filters. Let's go ahead and get back to the presentation. Dang it, Nagli, I always forget to ask you. Got anything else here, man? Do you use filters?
Yeah, actually didn't know about it even. So it's good that I learned as well.
All right, dude.
Yeah, it's very useful because sometimes you go to websites, even if you go to Wiz website, the main one, so many analytics, so many other stuff, when you need to track where the traffic is coming from, and so many noisy requests, and so you really want to have like filters that you don't need to mess all around, like every time do a new search, just have a filter that keeps the real meat, as you call it, that you want to see, like the API requests and the stuff that are more interesting. So definitely filters should be on top there.
Absolutely, man. All right, let's jump back to the pres. All right. All right, Nagli, we're back. We've talked about filters. Now you understand a little bit more about filters. Let's get into scope. Okay, scope is also important. It's actually personally not a feature that I use quite as much as I use filters, because I just use filters very intuitively. But it does actually have a big impact on what you see. So both scope and filters are designed to help you only focus on the pieces of the application that you want to see. Scope will allow you to set a specific set of host names that you want to see or not see. And you can select what scope you're using from the top left-hand corner. Right here, you can see example scope is the one selected, and modify those based on various spots you are in the app. The UI for that kind of looks like what I have down at the bottom here, where you can create a preset, and those in scope and out of scope fields there follow the syntax that you can see up at the top right. So you can provide sort of like a wildcard syntax. What I've got there says anything that has any host that has the name Kaido in it is something that I want to see. It's in scope, okay? So for example, Kaido.io would show up here, right? But Google.com would not, because it's not defined in that scope, okay? So this is another way for you to refine what kind of hosts you're looking at and what you want to see and what you don't want to see. Pivotal to navigating these very, very heavy HTTP environments of modern websites. You got anything on that, Nagli?
Yeah, just one point. Like when I focus on a program like Capital One, Google, or if I want to have a company named Kaido, so it's important to not put Kaido.io. It's really important to do wildcard Kaido wildcard, so you catch if they have other internal domains or other TLDs. So you really, or maybe SaaS product that they are using with like different vendors, that it has kaido.somevendor.com. So it's really important if you focus on a single company to not put like only the main root domain, like put a wildcard, then you might see more stuff that you don't want to miss.
Absolutely. Yeah. So just trying to simplify what you said there, Nagli, essentially, if you're loading up a website that you're targeting, right, there could be a service that they're using that's designed specifically for them, but doesn't live on their, website like google.com, right? It could be google.whatever SaaS provider.com, right? And if you just put Google, like I have there with Kaido, in the scope, then you'll catch even those other ones that are not necessarily the main website. That's what you're trying to say, right?
Yep.
Perfect. All right, cool. Yeah, that's a great tip. I always do that as well. Top minds think alike, man. They really do. All right, let's that should be it on scope. Let's jump into Intercept. Intercept is a really important part of Kaido as well. It allows the hacker to intercept requests and responses as they flow through the proxy and make real-time modifications to them. So actually, you know what? Tell you what, I'm going to jump back here a little bit to this interface, or this slide right here. You can see when we're intercepting, the request is flowing from your browser, and then it's pausing right here at Kaido before it gets passed to the target website, okay? So intercept says, whoa, hold up. I want to change some stuff first before it gets to the target website. It doesn't just observe. So you're kind of putting yourself in the middle of that whole setup here when you're using Intercept. Okay, so that's what we do. To be honest, I actually don't use it that often. I'd say, maybe 30-40% of the time. Because oftentimes I'm using some of the other tools we'll talk about later, but I think this is a really good tool for beginners to modify requests and responses and see what's happening actually in the browser. Okay. Yeah, my alarm went off. I don't know if you caught that, but I'm going to do what's happening and see what's actually happening in the browser. All right. So let's take a look at the Intercept interface. This is what it looks like. There's a couple things you need to know about. Number one, up at the top right, you'll see the queuing button. There's another state for that button, which I'm going to look at right now. It's forwarding, okay? So it could be green, could be that, pinkish red there. Essentially, what it is it controls whether requests are actively flowing through Kaido, or whether they're getting sort of stopped or intercepted, okay? You'll see the familiar HTTPQL bar from HTTP history up at the top. You can use that to filter what requests you want to intercept versus allowing them to pass through. You'll also see an interface where you can pause requests and responses. Now, depending on the version of Kaido you're on, this may look a little bit different, but the concept is going to be the same. you can select requests and responses to intercept and modify as they flow through. Then you'll see at number 4 and 5 there that we have 2 options. Drop, so this is don't forward the request to the website, or forward, which does forward the request to the website, okay? And those HTTP requests and responses that are represented here, those are both modifiable fields. So you can go in there, you can tweak stuff as it's coming through and sort of control what the browser is seeing and also what the web server is seeing, right, on the other side. Very helpful tool, and it is the first experience that we'll have in this course of actually modifying HTTP requests and seeing what kind of havoc that can cause on the servers. All right, so let's go ahead and jump into the next slide. That's going to be a lab called IDOR vulnerability. IDOR stands for Insecure Direct Object Reference, and guys, it is one of the juiciest vulnerabilities out there. So I think you're really going to enjoy this one. Head over to labs.kai.do, and we'll get into it. All right, Nagli, let's jump right into this lab, man. Here we are at labs.kai.do. This time we're going to click on the IDOR vulnerability lab. And the goal of this lab is to demonstrate how IDOR vulnerabilities work. And we can see here that there's just a single button on the page. It says show user information. When we click it, it shows our current user information, okay? Well, let's see what's happening on the back end, right? So let me jump over to Kaido here. I'm actually going to restart it so that you guys have a raw HTTP environment where you can see what's happening. Here we go. Okay, so the first request as it comes through is a request to idor.php. That's the lab that we see. We can see the HTML and CSS over here on the side, deciding how this page can be displayed. You can see right here, we're using an H1 tag, user information lab. If we switch over here, we can see user information lab in sort of big text, right? So that's the page that we're looking at. If we look at the next request, we see something a little different. We see a post, okay? It's very important to pay attention to these methods in the HTTP world. And with this post, there's actually a request body and a parameter that's being passed through called user ID, okay? So anyway, if you want to go and try to solve the lab by yourself right now, you can, but I'm going to get into the solution now, okay? So here we are. We can see that there's a user ID 1 that's being passed through. And if we scroll down to the bottom, we can see that it's showing data in this little box for user ID number 1, right? Well, I wonder what would happen if we did user ID number 2. So let's go ahead and head over to Intercept and pause that request as it goes through, and then we'll find out. So jumping back over to the lab, let's reset it, right? We're back at this page. This time, we go to Intercept, and we click queuing, right? So that you're intercepting requests as they come through. If we click the Show User Info button, now what's happening? It's stalling. The data isn't showing. Well, that's because Kaido has intercepted the request, and now we can modify it as it passes through. So we can see right here, we've intercepted one request. We've got our drop and forward buttons here, and we can modify what's going on here. So let's go ahead and see what happens if we change this 1 to a 2, okay? And we're going to press forward, not drop, right? Because we do want to forward the request to the server. Okay, we press forward, and we'll go ahead and unqueue and go back to the lab. And what is this? We can see the information for a different user, okay? This is one of the most common vulnerabilities and also one of the most severe vulnerabilities because, yeah, numbers are iterative. You can just keep going, right? You can look at number 1, number 2, number 3, number 4, and it's going to show you user after user after user. So with these, sometimes with these IDOR vulnerabilities, you can just dump their whole database of users and get access to a ton of private information. There's a little challenge here in this response for any of you familiar with hacker geek culture. We'll cover that a little bit later as we dive into this lab again using a different set of tools. But that's the solution for this lab. You can use this to find a different user's information by using Intercept and modifying the user ID from 1 to 2. Nagli, any thoughts on that before we jump back into the prez?
Yeah, I think it's also a good example. Like when I see 1, 2, 3, 4, 100, I try 0 or then -1, and then -1 might give you the last user sometimes, and 0 might give you all users sometimes. And
or a super admin
wild
user.
Card, like super admin or wild card. So yeah, even when you think like something is just numbers, you can try something. Like you always need to try and think what can break here and try some random stuff when it matters and when it makes sense.
Absolutely. That's especially important for a beginner, right? Try all sorts of stuff. The server is supposed to be robust. So if you find some way to break it, then that's a part of your job as a hacker, right? So throw whatever you want to at it and see how it responds, and you'll start getting a feel for how these applications are built and structured. That's a great call out, Nagli. All right, let's jump back to the presentation. All right, solid. We just found our first IDOR vulnerability. That is a very, very common vulnerability and one that you can find all over the place. So if you understand that, if you're kind of wrapping your head around that concept, you're going to be able to find a lot of bugs already in what we're less than an hour into this course. So very, very cool. Let's keep going.
First of many.
Yeah, first of many. Let's go. All right. Next up, y'all, is another 10 out of 10 frequency used tool, okay? So this is one we got a really deep dive. It's called replay, okay? And the purpose of this is to allow an attacker to maintain a list of interesting requests for the purposes of sort of tweaking and resending those requests to accomplish their goal in the application. This is where most hackers will spend the majority of their time, between HTTP history and replay, okay? Because HTTP history allows you to analyze these requests, right? And replay allows you to sort of easily tweak them and send it a lot of times without having to go through the whole intercept flow, okay? So let's go ahead and take a look at what that interface looks like. Okay, so this is the replay interface. Lots of things to cover. Hang in there with me. We're going to nail it, okay? So first of all, let's start on the left-hand side at point number 1 there. You can see that there is a session called 1, okay? Whenever a request gets sent to replay, it gets put in the default collection, which is like a folder or a group of requests. You can see that up at number 2. And it gets assigned a number, based off of what order it was sent into replay. You can always, right-click or double-click on these sort of cells that represent the sessions and rename. You can see I've got, if you look at number 4 there, I've got a tab called XSS up there. That's another vulnerability type. And I've renamed it, so it makes it easy to find. You can see over at number 3, we've got a search bar where we can quickly try to find requests that we've sort of categorized away and stored inside of replay. It's a really great environment for doing that sort of iterative testing. If we look at number 5, we can see the bar there that allows us to send the HTTP request that you see in the request and response panels that you see at number 6, and the response on the right side of the page. You'll also notice there's a back and forth sort of button right next to the send. This allows you to sort of scroll through the various things you've tried in the past. So, maybe like Nagli said before, you put in, a letter into your user ID and it gives you an error and you're like, okay, I don't like that. And then you try, -1 and it gives you an error and you're like, and then, but it gives you a different error and you go back to the first one and you're like, oh, that's a different error. And you start piecing together how the application works, right? So it's important to be able to use those back and forth buttons to try to understand how different tests resulted in different outcomes and start correlating the functionality of the application. So little bit of a rant there, but man, I freaking love that. I really do. It's such a valued part of hacking for me. All right. I guess going sequentially, at number 7, we've got the area where you can create placeholders. We'll talk about that a little bit later, but just know that you can sub in various pieces of data into the HTTP request using placeholders. You do that via that clear -+ button at number 7. At number 8, you'll see down at the bottom that there's a pretty print button. This allows you to control whether the HTTP request is sort of highlighted and made pretty, so it's easier to read. Sometimes you want to turn it off so you can see exactly what's coming over the wire, but most of the time you want to keep that on so it's a lot easier to read. And just like in HTTP history, if you right-click on this request, you get a bunch of different options: copy to curl, copy URL, paste, duplicate the replay session, and you also get the ability to run various workflows on that, which we'll cover in a bit. One thing that is a little bit special here to replay that I didn't actually highlight here in the slide is if you look at third from the bottom, there's the set request button. This is helpful if you have a URL that you want to just paste into Kaido. you can just use the set request button there, and it will generate an HTTP request for a given URL. Kind of helpful. All right, cool. So that's replay. Let's go ahead and take a look at that IDOR vulnerability lab again and use replay to leak various users' information. All right, let's go to the lab. Alrighty, y'all, we're back. Let's go ahead and take a look at this IDOR vulnerability again, this time using replay as a tool to exploit it. So let's hop into the lab over at labs.chi.do. Let's open it up and click the show user button. This will generate that post request on the back end, right? So let's go ahead and head over to HTTP history in Kaido. And yep, we see the GET request, which generates the HTML page. And we see the post request that contains the user ID, right? So this time, instead of having to use Intercept, we're going to do something a lot easier. We're going to right-click here. We're going to go to Send Replay and click Default Collection. Or you can use the keyboard shortcut Control-R. I'm on Windows, might be Command-R on Mac. I don't know. I'm not a Mac guy. You know, it is what it is. We won't get into that today. But if we head over to Replay, you know, you can see there's a little number right here at Replay. Shows that you sent something to Replay. And boom, we can see the request that we are trying to play with, okay? So maybe if I was hacking on this, I'd be like, I'd take this and I'd title it IDOR vuln in user ID, something like that, right? Okay, and let's go ahead and click send, and we can see the base response, right? Here we go, right here. There it is. And now we can easily come over here and modify it. Change it to 2, press send again, scroll all the way down to the bottom, and yes, we can see the information that we were trying to leak. Now let's go ahead, Nagli, just kind of going back to what you were talking about in the previous section, let's go ahead and see how the application responds to an A. Okay, it gives it 200, and it says user not found. Pretty weird, right? Let's try like a -1. Right? I'm going to press Control Enter to send, right? User not found. Now, if I wanted to go back to that A, I could press this back button right here. User not found. Okay, those error messages are the same. So we know that it's treating an A and a -1 in the same way, which is a little bit weird. It's because of the weird way I coded this. So my bad, a little bit funky, you know, but it does highlight the example of, you know, you want to try various things with this and see how the application responds and try to correlate weird pieces of functionality together. So now we've got a replay tab with this vulnerability. And, you know, if I was in a bug bounty setting, what I would do is I would, you know, start to go write my report. And then when I'm writing the report, I would just, you know, grab this whole request, copy paste it into the report so that the people receiving the report can investigate it for themselves and reproduce the vulnerability and then pay me that sweet bounty money. So yeah, any comments on that, Nagli, specifically using replay to find this vulnerability?
Yeah, maybe I'm a little less optimistic than you. I'm always naming my tabs like maybe IDOR or maybe vulnerability because we need to find it first. But yeah, other than that, like if I see the errors are the same, user ID A, maybe you could try admin, you know, like sometimes you could also try user ID for a number and for a user. But yeah, replay is so much easier, right, to send many requests. No need to intercept every time, just super easy like that.
Yep. All right, cool. Let's go back to the presentation. Alrighty, y'all, we just completed the IDOR lab using replay. We are going to jump into a next section that actually also relates to replay. So keep your tab open there in replay. And this is replay collection. So we talked a little bit about that before, but guys, it's really essential you know how to use these well, because what's going to happen is once you start getting through those first like 500 requests, like we talked about before, this is going to get real clogged, okay? So I want to show you some ways really quick that we can stay organized within Kaido. So you'll notice that, actually you can't see it in this screenshot, but in the default collection there would be a tab called get/, right? That's what it's called up here at the top. And so it's kind of in two spots. It's in the collection on the left-hand side, but it's also up at the top, right? The ones at the top are the ones you have open, and the one on the left-hand side are the ones you have in the collection or stored, okay? So at any time, you can use the X button to close that session, and you'll still be able to find it in your collection on the left-hand side. You can also right-click on that session up at the top, and you'll get access to a bunch of things like rename, move, and all the guys, Frick, I love this part so much. The close left and close right, I use that all the time when I'm hacking. And it's because I've got like certain points within my hacking. And I'm like, okay, this is where I went down this rabbit hole. I'm done with the rabbit hole. I'm just going to close all of the ones to the right of this and go back to where I started off, right? And you've also got the ability to create other collections. You can see in this screenshot, I've actually created a collection called gadgets. This is something that I do a lot. Gadgets are pieces of functionality on the website that can help you create a vulnerability, right? They do something for you, but they aren't a vulnerability in and of themselves. So it's like a piece of the puzzle, right? In this specific example, I have client-side path traversal gadget there. It's very helpful to categorize these gadgets in various collections. All right, so let's go ahead and create a vulns collection and put that vulnerability we found into that collection. So let's jump into the lab. Alrighty, y'all, we're back in the lab. This time we're going to go ahead and create a collection, and I'm going to talk to you guys a little bit about staying organized here, okay? So right now, I don't have any collections. I'm going to press this little down button up at the top left-hand corner, create a new collection. You can double-click on the name to rename it here, and I'm going to name this one vulns, okay? And then now it's an empty collection. That's kind of sad. Sometimes the vulns collection is empty. Am I right, Nagli? Sometimes it is, right? It's a part of the game. But we did find a vulnerability. So we're going to right-click on it, and we're going to hit Move, and we're going to click Vulns, okay? So now this active session is in Vulns, so that's why it's highlighted. And if we click down, we can see IDOR vuln and user ID, okay? And that is categorized here. Now, if you're ever looking to, like, say you've got a ton of requests, and you're like, where's that IDOR? You can type IDOR here, and it will search based off of the name of that tab, but also off of, like, stuff like the host that you're sending it to, the verb, the path, so various pieces of the HTTP request have been indexed and are searchable for you here. All right, super easy lab this time around. Nagli, you're not the most, organized person that I know. Do you use this functionality in Kaido?
Nope, not really. But I did want to. I did want to know to the listeners that if you're really in the zone on the program and you really hack it for like a week, you should expect to have hundreds of reply tabs here. That means you're really hacking and you see a lot of interesting stuff you want to examine and play with. So definitely don't be afraid to send as many requests as you want to the replay tab.
Totally. Great advice. All right, let's jump back into the presentation. Let's go ahead and jump into the next section, which is also related to replay, okay? I kind of alluded to this a little bit before, but those buttons that you see near point number 2 of the presentation that's currently on the screen allow you to create what are called placeholders within your replay requests. And this allows you to do some automation or subbing in of certain text into certain spots in the HTTP request. So the example that I've got here, I'm subbing in an authorization bearer, right? This is what identifies me to the server. And I am supplying that via a environment variable that you can see over at number 4, okay? So I'm going to walk you through that real quick. So how I did this is I selected the 0 UUID that you see there on line 3, right, at number 1. I selected that text, and then I pressed the plus button that you see over at number 2. Then that popped up the little yellow selection area there, and you can press the button that's highlighted by 3, which is the edit button that sets up the placeholder settings. Okay, on the left side, you've got the input that you want to pass into the placeholder. Sometimes this is, by default, that's whatever you selected, but also you have the ability to select the whole request if you want, to pass that into automation to process what should be substituted for that selected portion, okay? So once again, what you've got on the left side of the placeholder settings there, where you see the request, is what data you want to pass into the next step, okay? And that makes a little bit more sense when we talk about workflows being used here, which is our automation framework in Kaido. But for now, the example I'm going to give is we're going to use an environment variable, okay? What is an environment variable? Justin, you haven't explained environment variables. Yes, that's true. I know. I'm going to get to it in just a second. But essentially, it's a way to store key value pairs within Kaido, okay? So what I've selected from that environment is my API key variable, and I'm going to substitute that into the request, okay? And then if you look in the response plane where I've highlighted at number 5, you can see that the auth bearer is not 0000, whatever, like I specified in the request. it actually ends in 1337, okay? And that shows that the API key is actually being substituted in from the environment variable. This is really helpful for storing session keys, storing API keys. If you don't know what that is right now, don't worry about it. You'll understand eventually. And just know that you can substitute values for various you can store text and substitute them into replay without always having to type it every time. Very useful functionality. All right, I promised that we would get into environments, and boom, here we are. I ain't the one to tell a lie. We're going to talk about environments. This is another section of Kaido, and the purpose of this section is to allow the hacker to define variables and store data that will be used in various parts of the Kaido app, okay? It's useful to store IDs, API keys, auth cookies, etc. I've even used it in the past to store RPC ID to path correlations, which you don't know what that is, but it's okay. Don't worry. I'm just excited about it, okay? So let's go ahead and jump into how this tool is used. So here's the interface. Of course, you can select it from the left-hand side as always. There is a global environment that is the default. That's fine for you to use. Or you can also select various additional environments, which you can create via the new environment button at the one indicator there. And then you can select the environment you want to work within at 2 in the little panel on the left-hand side. Now, by default, you're not going to have anything in your environment, so you'll write a name for it, and then you'll press Add at the right-hand side. You can configure a variable within it manually, or you can also use our workflows to update variables, which is what's very useful. We'll talk about that later. But in this scenario, I've defined a static auth bearer environment and given it the value of 0 GUID, except for the end is 1338. And then I press the update button down at the bottom. And actually, if I'm not incorrect, depending on what version of Kaido you're using, you may need to press a little save button that's kind of near the trash can there on the screen before you click update. We're working on streamlining that process. So by the time this comes out, hopefully you won't, but just in case, there might be a save button there as well. And then I didn't highlight it, so I'll just kind of select it with my cursor here. You can see up at the top that there's actually the ability for you to select what environment you're in. So right now I have the user 2 environment selected right here for the global context for Kaido. So when I'm in replay, we're using user 2. When I'm in running workflows, we're in user 2. And you can change that by selecting this dropdown, which is right next to the project selection interface in Kaido. Very useful if you've got like 2 accounts, right? Let's say Nagli and I both have accounts. We're hacking on a live hacking event together, or we're just working on a bug bounty program. Nagli gives me his account auth bearer. I give him my account auth bearer, and we store these inside of environments, and we're trying to attack each other's accounts, okay? This is also helpful with IDs and stuff like that. So helpful functionality. I use it primarily in an automated fashion in conjunction with workflows, which we'll talk about a little bit later. Oh, wait. We're going to talk about workflows right now. And Nagli, before we jump into workflows, is there anything that you wanted to mention about environments? I know that this is a little bit of a niche feature.
Yeah, just like, when you hack, as you said, like some live hacking events, if you want to collaborate with someone and you have these UUIDs, sometimes the very long strings, you ask a friend over Discord or Slack, hey, can you give me your user ID? And then you need to replace it. You put it like, if you're not organized like me, you put it in the replay tab somewhere and you put it in the notes, or you just keep it in the Discord and you need to open it every time. So environment variables will make it way easier to do this kind of stuff.
Way easier. Yeah, it is a trade-off though, Nagli, which like there's a little bit of friction sometimes. It takes a little bit of mental energy to be organized and stuff. And what we're striving for a lot with Kaido is we want the hacker to be in a flow state where they're so focused on the application, they're so focused on the HTTP content, they're not really thinking about using Kaido. But sometimes it does take a little extra effort to kind of get those habits in place of staying organized. So these tools are there if you want to use them. Alrighty, y'all. Next section is workflows. Let me talk to you a little bit about this, okay? The purpose of workflows, as designed by Kaido, were to allow the hacker to do sort of quick and dirty, or I call it just-in-time automation, last-minute automation, to accomplish their goal, okay? And so you can see sort of on the right-hand side, a low-code, no-code interface that we've built for helping you make these automations that will streamline your workflow, okay? That's why they're called workflows, streamline your workflow. And workflows have 3 different types: convert, passive, active, and we're going to jump into those now. I actually use workflows a ton. There are people that use Kaido that don't use workflows a lot. And I guess as a beginner, you should really be focused more on just the HTTP request, sitting in the HTTP requests, understanding what's happening, trying basic logic vulnerabilities with Intercept and replay. But I do want to make you aware of the workflow functionality so that when you do advance, you can start using some of these workflow tools to make you a more efficient hacker. So let's just take a little deep dive into that real quick and take a peek. So these are the types of workflows that we got. As I mentioned, there's convert, passive, and active, okay? They each do different things, so try to listen to the differences between them, okay? Convert is a text in, text out workflow, okay? So you're selecting something from your HTTP request or your response or from somewhere, and then you're applying some sort of transformation to it, and then you're producing output text, okay? There's lots of things that we could talk to you about here, like base64 encoding and URL encoding. That's probably best served in a different segment. But the sort of quote that we gave you for this, so you can think about it in your mind, is like, pretty print this data. Make this data that I'm looking at here easier for me to read on the screen, okay? So that's one of the things we use convert for very often. And there's lots of tools that you can use within the convert workflow design interface to make the output much more readable, or get the data in a state where the application is ready to receive it, because sometimes it needs to receive the data in like a certain format for the request to work. So convert can help you with that. Next is passive workflows, okay? This one I kind of want you guys to think of as triggering automation on the request and response coming through Kaido, right? So we remember that graph from before where the data is flowing, from your browser into Kaido over to the website. Well, passive workflows trigger every single time data flows through that segment, okay? And we can use these for various things. The input is a request to response pair into the passive workflow, and it doesn't block the request going through Kaido. It just runs as well, okay? A useful example of what you might use a passive workflow for is, for example, for every response that I see come through Kaido, look at the data and see, are there any AWS keys in there? Okay, what are AWS keys? AWS keys are a piece of sensitive information that you can use to take over a ton of websites for a specific company, okay? So if those are in the response, then you definitely want to know about that, because then you can just log in and take over a bunch of websites, right? So passive workflows can be used to try to check the response every single time. Say, hey, is there any AWS keys in here? Nah, okay, all right, we're good. Or, yes, there are. Holy moly, let me create a finding and draw this to the user's attention, okay? So that's passive workflows. Last is active workflows. These are automation triggered by user action. So you'll remember earlier when we right-clicked on some of the request panes in HTTP history or in replay, that there was a run workflow button. And that run workflow button allows you to trigger workflows directly on a specific request. One of the things that we've used this for in the past is taking a specific request and handing it off to a different piece of automation that we've written, maybe in Python or in Bash, because you have access to shell out from an active workflow. And so, once again, a little bit power user tools here, but something you should be aware of as you become a power user, which I know you will, okay? You can do this. So be aware of these functionalities. All right, I think that's oh yeah, here we go. This is where you can see how to trigger these workflows. You can see up at the top, we've got actually the replay placeholders. Remember when we talked about that earlier? We can run a workflow, these automations, whenever we press the send button in replay, okay? So that's very helpful for encoding data, getting it formatted in the right way. You can modify it in the format that works for you, but then when it sends to the server, it's in the format that the server is expecting, like base64 encoded or something like that. Very cool. Another way that we trigger workflows is via the request response right-click menu, like I mentioned. You've got a couple options here. Let me break them down. One at the top is convert preview. Okay, so that takes the text that you've got selected currently, runs the workflow on it, and then shows it to you in a pop-up box. Okay, that's useful for like getting some introspection into the data. You've also got convert replace. Okay, this takes the selected text, runs the workflow, and then puts the result right back into the request where you selected. Also very useful. And then right below that, you can also see the run workflow. Here it is right here. This is where you trigger those active workflows that we talked about before, okay? Last but not least, we have the ability to run these workflows from keyboard shortcuts. So getting into power user territory again, but if you find yourself using convert workflows a lot or active workflows or whatever, you can actually bind a key binding to them and make it really easy and quick to run those workflows within Kaido. All right, so that's kind of like how to run these workflows, how to get those rolling. Obviously, passive workflows don't need any triggers because they're running on every request and response. But for active and convert workflows, these are how you trigger them. All right, hackers, next section is automate. Automate is super essential. Let me tell you about it. The goal of this is to allow the hacker to send HTTP requests in a specific pattern in rapid succession with a predefined input. Okay, what the heck does that mean? Well, for example, if we were going to go and exploit those IDOR vulnerability from before, right? Maybe we'll come back to that, who knows? You don't want to manually have to say, all right, let me dump the database here, user ID 1, user ID 2, user ID 3, and just press, send every time. You want to have some way to automate that, and you can do that with automate. Let me disclaim, though, when you are finding vulnerabilities in Bug Bounty, it is very essential that you do not use this tool to dump the database. In Bug Bounty, we provide a proof of concept, is what it's called, a POC, that shows the vulnerability without fully exploiting it to its full extent, okay? So if you find an IDOR, do not dump every single user in the system. Dump 5 and then send the report, or better yet, 1 and send the report. And then that's the responsible behavior here, okay? So we're enabling you to do some stuff now with automate. So be careful. With power comes great responsibility. You're going to rock it, okay? The other useful thing here is not just for, iterating numbers, but also you can do some fuzzing to try to identify odd behaviors. So let's say you had a list of things like Nagli was mentioning earlier, A, -1, 0, a bunch of different things. You could put those into a list and have automate automatically try them for you, and then just look through the results yourself. So we'll see how to do that in just a sec. Here's the automate interface. Let's kind of jump into the various components of it. On the left-hand side, you see the familiar sort of collection-like interface. Up at the top, we've got our sessions defined, and we can see the request that we're fuzzing on here at number 2, okay? You can also see that we've defined a placeholder or a payload here, right, where we want to insert some attack, okay? You can see it's sort of a similar situation to what we did on the lab earlier that we've got here in the slides, where you're trying to enumerate a different set of users' informations here. So once you select where you want to put the placeholder, you can press the little plus button that you see over at 3, and then it'll pop up this portion on the right-hand side where you can define various payloads. So if we look at the one we've got here, we've selected numbers, and we're doing 0 through 100, which is exactly what I told you not to do. So do not do this in a scenario that is not, you're not authorized to, or is not a lab, okay? But you do need to understand, that it's possible to do it. And it is helpful in some situations. So that's why we're equipping you, okay? So this will allow you to do 0 through 100. Let me add a little bit more of concreteness to that. There are situations where the IDOR isn't necessarily iterative, right? It's not 1, 2, 3. It's 1, 18, 48, that sort of thing, right? So if you get a response back on 2, that's like, user not found. And you're like, okay. Well, maybe I don't have the right ID. So then you try a bunch of them, and if you see user data coming back, you immediately hit pause, right? But it is sometimes useful to brute force these if you need to, okay? Use it responsibly, please. This little segment that I've got here in the middle is actually the preprocessors tab. So this one right here, you can kind of see what it looks like. We have the ability also to define not just the payload, but how the payload is processed. So in this scenario, we've defined numbers 0 through 100 as the payload. How are we going to process that payload? Well, we can run it through a workflow, a convert workflow, right? Because convert workflows are text in, text out. That's a great way to do it. You can select those using these drop downs right here. You can see the one that I've selected right now is not actually a workflow, even though you could do it with a workflow. It's called URL encode, and it takes a specific set of parameters or a specific set of characters and represents them in a different way. It's a common thing. Might be covered somewhere else in this course, not sure, but if not, it is good homework for you to look into URL encoding. So this is the gist of how you use Automate. This will help you try to enumerate a bunch of requests very quickly and try things sort of in a pattern that you would like to attempt exploitation, so you don't have to manually type it out in replay, then press send, then press send, then press send. Nagli, any thoughts here on your usage of Automate or how this can be helpful to the hunters?
Yeah, I think the best example is just when you have like every time you have 2FA, right? Or you have like 4 digits, 5 digits that you need to enter, 6 digits. That's the most common use case for it. If you see 4 digits, that's always suspicious, and you need to check if there's no rate limiting, so you can really do like from 0 to 9999. Then it means you can maybe take over accounts, reset passwords, and other stuff. So every time you see now, from now on, because of this course, every time you see like 4 digits required to authenticate you to something, maybe it's buggy because you can just automate it very easily.
Yeah. And dude, every single time I log into some service and I'm like, oh man, it's a 4-character pin. Like I could use Automate.
I hope I'm not screwed. I hope I'm not screwed.
I hope I'm not like gonna get hacked here. But reminder, do not test things you are not authorized to test. That is illegal still. So please do not do that. All right. So we talked a little bit about Automate. Let's, put some action behind those words. Okay. We're gonna go back to the IDOR vulnerability one more time. And this time, we're going to use Automate to iterate through all the user IDs that we got. Okay? Yep, let's do it. Let's jump into the labs, labs.kai.do. Let's go.
Okay.
Alrighty, guys, here we are in the lab again. Let's take a look at the IDOR vulnerability. Once again, we click Open Lab. Here we are. We click Show User, and we know what's in the background for this request, right? We know that post request is there. So let's go take a peek. All right, here we are, HTTP history. Here is that post request right here. And instead of right-clicking and hit send to replay this time, we're going to hit send to automate, okay? So now we see that familiar little sign from before, but this time it's an automate. And we're in the automate interface where we can define payloads and preprocessors and that sort of thing. So the place where we would like to iterate is on the user ID. If you want to go ahead and get it set up yourself, go for it. Pause the video here, go knock it out. If not, I'm going to show you how to do it right now. So pause it. Okay, if you're here, it's your own fault. Okay, all right, let's go. Let's select one right here. So I've selected the text. We're going to press the plus button, add placeholder at the selected position. Very useful, thank you. And now we've got a placeholder here. Okay, and we've got a bunch of various options here. And I should definitely mention the fact that it is also possible for you to select a hosted file. So you can create a file with a bunch of different type of payloads that you want to put in here, okay? In my recording instance, it looks like I don't have any files created right now. We'll go into that a little bit later. But you could also select those here if you want to use a word list to do brute forcing. Another option is simple list. If I wanted to just type in here, I could just do ABC, blah, blah, blah. And I could also load that from a file or just paste it in. This is very useful for like quick and dirty brute forces. You've got null payloads. If you just need to send the request a certain amount of times, you can use null payloads. This will send the request 1,000 times without modifying. And then numbers, which is the one we kind of talked about before. Okay, so we'll stick with numbers for this one. Let me explain what each one of these does. The start is where obviously it starts, end is where it ends. Increments, this is the amount of the number should increment each time. So we're doing incrementing by 1. So we're going to do 1, 2, 3, 4, 5, 6, that sort of thing. If we increment it by 5, be 5, 10, 15, 20, that sort of vibe. So you can control that as well. If you're looking to kind of get like spray across a certain space, then it might be helpful to use increments. You can also do zero padding on this. So if you would like, I'm just going to come up here. If you would like to see the number 0005, okay, so it's blocking me out now. But it's like if you wanted to do 0005, right? then it's kind of hard to do that across the full space. So like Nagli was mentioning before, maybe you get a two-factor authentication pin coming in, you're trying to brute force it. So even though it went to Nagli's phone, I can still get access to his account. A lot of times those are always going to be 4 characters. So you're going to want to do the padding here to get, the minimum digit set to 4. So even if they're guessing the number 5, it's represented as 0005, right? Hopefully that makes sense. If not, maybe the editors can put something magic up on the screen that makes it make a little bit more sense. We'll see. All right, let's leave it as it is for now. We're just going to drop the minimum digits down to 1 or whatever the default was there, 0, maybe. And then we can take a look at preprocessors. URL encoding is the default. You could use it, you could not use it. It doesn't really matter in this scenario. And then if we go to the settings page, you can sort of see some more granular settings. These ones I'm not going to cover, but I will say when you are brute forcing sometimes, it helps to set a delay between each request. A good delay is like maybe 100 milliseconds or maybe like 200 milliseconds or 250 if you wanted to be a little bit slower. But it's really important you also remember how many workers are doing this. So this is 10 workers sending a request every 250 milliseconds. If you want a request to be sent every 250 milliseconds, then you need to set this to 1, okay? So keep that in mind when you're brute forcing. If you want to go a little bit slower, you're not going to break the server. Maybe you won't trigger rate limiting, that sort of thing. So keep that in mind, okay? I'm going to go ahead and move workers to 1, and I'm not going to delay at all, okay? So let's go ahead and run this and see how it goes. All right, we're iterating through each one. We can see right here, if we click on the 0, we're not getting anything here. Let's click on number 2 here. Oh yeah, here we are. We can see the data for user number 2. You can sort these columns. These columns are sortable. So if we want to see, the latest requests or the ones at the beginning, then we can sort this as well. And we tried 100 different requests here. Now let's remember that trick I told you earlier about looking at the response length. Okay. We can look at this here, but all of these kind of look similar, except for number 1 is a little bit different here. Number 2 is a little bit different. Maybe we should sort by this. Okay. So we come up to the top, we sort by length. And what do we see here? There are actually 3 outliers here that don't have the value 4495. We got 1, which is us, 2, which was the user we attacked before, and user number 42, okay, which is the actual admin, super secret internal user that we were hoping to compromise. It also gives us access to his secret key that we can use to take over the whole website. So this is how you use automate to enumerate over a large space of numbers, right? And like Nagli said, another really great use case for this is brute forcing those two-factor authentication codes. And there's countless uses of this throughout application, web hacking. But this is how you solve this lab. Nagli, did you have any comments on this as we close?
Yeah, just every time we do automate brute force, we want to look for the outliner of the content length, like you mentioned, because even if you brute force a number, then let's say 4 digits, we want to know what succeeded. We want to check which one the length is the different than all the other 9,999. So always like when we do a brute force, our intention before we even started, we are looking for an outliner that will give us the results we're looking for.
Absolutely. And actually that makes me think as well, we actually have this HTTPQL query bar here that we can use. Okay. So let's go ahead and try to use that to filter out the responses that we don't want to see and focus only on the ones that we do. So one of the ones that we don't want to see is this 4495 that says user not found. Okay. So one of the ways that we could do that is by saying, hey, don't show me anything that response.raw.contains user not found, or maybe it like not contains user not found. That'd be one way. But you can also do it after the response length. So if we do response.length not equals, right? And then we do something like this, 4495. Okay, now we just have these 3 outliers here that we can investigate into a little bit further. Okay, so HTTPQL, really useful to get your hands dirty with, and allows you to really filter and focus in on the meat of the application as for hacking. All right, let's jump back to the press. All right, we just finished the Automate IDOR lab. You guys are killing it. You got a ton of vulnerabilities under your belt now. Let's jump into the section that we sort of alluded to inside of Automate, which is files, okay? The files section you can find on the left-hand side as well. The purpose of this is to store word lists for use by the hacker, okay? You can see here on the right-hand side, I've got a bunch of different files that I've uploaded. These are actually like the ones that I use, so maybe I shouldn't have uploaded those, but it is what it is. I share the love around. One of the ones that I really like to highlight here is all URL encoded ASCII characters. So that's %00 through %ff. Super helpful word list. Use that all the time. So this is a area where you can create those word lists that we talked about to feed into Automate. So let's take a look at doing that, right? It's very simple. All you do is you press the upload button at the top right, select the file from your file system, and it gets dumped right into the files interface. One thing that I will note here is that these files actually live on the server side of the client-server architecture in Kaido. So if you've uploaded these files to your Kaido instance and you switch from your desktop to your laptop, but you're still using the same server, right? Your files are going to be right where you left them, which is great. And it makes for a very consistent hacking environment. All right, we got a quick lab for this one. Shout out to our friends over at SL Cyber. They make the most amazing word lists out there, guys. Really, they do a lot of data science and querying of public data sets to create these really, really powerful word lists. I highlighted two here, HTTP archive directories, HTTP archive parameters. These are ones that I use on a regular basis. So go ahead and grab one of these from tools.slcyber.io /tools/wordlists and give it a shot, upload it into Kaido. I guess we could jump into the lab for this. Nagli, I don't know if I want to share my upload prompt, but we'll figure it out. Let's head to the lab. All right, guys, here we are in the lab. If you're trying to access the word list from SL Cyber, they do require you to make an account. It's still free. Don't worry about it. Just go make an account. I'm going to go ahead and log in, and you can see, let me get that out of the way, that there's lots of tools that SL Cyber is offering, but the ones that we're interested in today are word lists, okay? So you go to this word list thing on the side here, and you can download any of these and upload them directly into Kaido. So for now, I'll just go ahead and grab this HTTP archives directory. Note that it will go a little bit slower if you're proxying, okay? Because Kaido's processing all of that data that's coming through. But you can download it, and then let's go ahead and upload it into Kaido. So I'll switch to my HTTP proxy here. Over to Kaido. We'll go to Files, Upload, and then editors just blur this out. Okay, we'll go ahead and go to Download and click HTTP Archive right there. And boom, now we've uploaded that file into Kaido. This now lives on our Kaido server and can be used from my laptop, my desktop, whatever, as a part of the Automate hosted file word list interface. So that's how you use files there. I use this pretty often. It's not like my most used thing. A lot of times I'm actually using workflows or numbers, right, as the values for my Automate brute forces. But it's definitely something to be aware of either way. Any thoughts on this one, Nagli, as we leave this lab?
Yeah, so we have these big word lists, huge word lists actually. If some repetitive tasks that we want to do, usually I find myself, I want to brute force some passwords, maybe 100 passwords or maybe 1,000 API endpoints. So I just go to GitHub, I write small API word list or small password word list. You will find a lot of stuff there also. So if you need for ad hoc, maybe some smaller word list, you don't need to download it or upload. You could just do even copy paste on the Automate before. But just so you know, more places for word lists, github.com could be perfect for this ad hoc stuff that you want to do. And of course, you have these sources that maintain them all the time and host this data continuously. Very
nice, man. Yeah, absolutely agree. That whole point about brute forcing word lists or passwords is another great use of Automate and something you will definitely need a word list for. Because a lot of times in these organizations, if you can just get a list of emails, gal.nagli@wiz.io. Okay, then we've got we take that same format, first name, last name, @company.com or whatever, and then we put in a bunch of names in there and we try all of those common passwords. And then really, honestly, like pretty often you'll get a hit and be able to log into the application that you're trying to hack. Very useful technique. Alrighty, we just got back from the files lab. Hopefully you guys understand that a little bit better now. Let's move to another section. This is actually another really highly used section. This is search, okay? And the purpose of this one is to allow a hacker to query the current database of HTTP requests using HTTPQL to identify a set of requests that meet the condition that you supplied. Search has a little bit more functionality to it than just using HTTP history, right? They're very similar, the two, but search has some things that you should be aware of that I'll show you, okay? This is the basic of the search interface, but I'm actually going to jump into the Kaido environment so I can show you a little bit more after this. So first up at the top, of course, you can see the familiar HTTPQL bar where you provide your query. You can also see that there's the ability to export all of the rows that you see here, and all of the requests are showed in that sort of familiar HTTP history-like table so that you can click through and figure out exactly what you want to find. Now let's go ahead and jump directly into Kaido, and I'll show you what I would like to highlight different from what we have here on the slides. Okay, so here we are in Kaido. If I go to the search tab, you can see all of the different requests that I've made recently. Some of the ones to SL Cyber for the files lab, and the ones for Kaido labs for the automate challenges. Okay, so we can select each one of these, and you'll notice that there's a source value right here in the table. So you can see requests coming from Intercept. That's just flowing through Kaido's data. You can see ones from Automate, right? And you can also see ones from Replay right here, right? When workflows also create requests, you can see those here in search as well. Now we covered HTTPQL query bar, but we didn't touch on advanced yet, where you can select the source exactly here on the right-hand side. You can see we've got a sample, workflow, plugin, replay, automate. You can select from there. Or you can define any of your filters that you'd like to have applied to this search, okay? You can also apply a lot of those. You can see the ones that have applied from this interface right here. Also, I didn't cover this in HTTP history, but I love this little jump to row button that takes you back to where the current request that you've selected. I think that's what I had for search. Nagli, anything you want to add in here?
No, just that it's useful to get all the resources aggregated. Like sometimes you made on the reply request 57, you made a response that you need now for a POC, proof of concept, or to highlight again, and then you lost it, like you don't know where it is. And it's not in the HTTP history, right? Because you found it from either automate or replay. So it's important to have one centralized search place for that.
Yeah, totally. It's very essential. And oftentimes you're looking for specific values that you saw earlier on, and this is the place to search for those. All right, so we just finished the search deep dive here. Let's move to the next section. Guys, I freaking love this section, okay? This is like, I use all the other tools a lot. Match and replace is like one of the things I'm most passionate about though, okay? So let's talk about that. Match and replace allows the hacker to specify a set of automated rules which will match a certain string or regex and replace the mask portion with a different string, okay? It's crazy cool vulns come out of this, super easy to use. Let's jump into it, okay? All right, so this is what the match and replace interface looks like, and by the number of little things I want to draw your attention to here, you can see that I really love this and that I think it'll be really helpful for you. It's a very built-out tool. Kaido's invested a lot of resources into it, so I think you'll find it great. So you can select match and replace from the left-hand side to create a rule. And what it does, as mentioned before, is it just kind of subs out some text on the fly as a response typically comes back from the server. But you can also do it on requests if you want to add headers or whatever. So at number 1, you can see the interface to create a new rule. And the rules are defined on the right-hand side here. There's lots of different sections. The first section is section. And that is the part of the HTTP request that you want to do a match and replace in. So in this specific environment, we've selected the response body. So that's when a response is coming back from the server and is about to be shown in our browser. The reason why we often select response body when using match and replace is because listen closely to this one, guys. One of the most important uses of match and replace is simulating a specific application state in your browser that is different from what the server believes is happening, okay? An example of that would be if the server responds to a request and says, this guy is not an admin. Admin equals false, right? And that's coming back in the response. You can set a match and replace rule that says admin equals true, right? And set that. And now your browser is going to, when it renders the page, it says, oh, admin true. Here's the interface that an admin would use in this application. And then you can click around on that interface and try to see what HTTP requests are being issued to the backend and double check that those HTTP requests are not being processed by the backend, right? Because if they do allow you to do that, then wow, you've just done an admin action with a non-admin account, okay? So match and replace is very useful for simulating a state on the client side or in the browser. Yeah, that's an important concept. So try to think heavily on that, and we're going to do a lab with that in just a second. Okay, so let's talk about the nuts and bolts of how to get that done. So in section 3 and 4, you can see the matcher and replacer. These are the ways that you specify what you would like to match and replace. So here in the matcher section, I've got string selected. I would just like to match this exact text. Matcher here, and I've got string selected for replacer as well. I would like to replace exactly this text, okay? At number 7, you can see an HTTPQL condition for this. This is if you only want the match and replace rule to apply to a specific request. Sometimes you just want to say false is true, but only for the am I an admin request, that sort of thing. You can do that with HTTPQL. You can update and test the rule, the request or the response body that you see at 10 and 11 represent the before and after of this rule being run. So if you press the test button, then you can see that the key no longer is matcher here. It is replaced value here, right? So you can test your match and replace rules live before you run them. Now, this is a very essential piece, okay? The way that Kaido is structured, we've made an intentional decision to not automatically enable the match and replace rule as soon as you save it, okay? So you will need to enable the match and replace rule by selecting those orange square next to the name in the left-hand side under the default collection. That is how you enable the rule. When you do that, you'll see the active rules, down at the bottom populate, and you can actually reorder the structure or the sequence of those active rules that you've got in the active rules section by dragging them around. So if you want one to run before the other, then you can define that sequence in active rules. Okay, that was a lot. Hopefully you guys sort of wrapped your head around that. But if not, let's go ahead and take a look at the lab and see if we can further your knowledge a bit more. Okay, so this lab is match and replace. You can find it at labs.kai.do. And what we're looking to do here is simulate John being an admin and having access to all the features, or specifically, guys, the Sparkle background and admin features, okay? So let's go ahead and dive into the lab. All right, here we are in the lab now that we're through Nagli's jokes. And we're going to go ahead and jump right into the match and replace lab. We can find that right here. I'm going to click Open Lab. And you can see it shows you a page where you are John, presumably. And John has the basic role. And there's no features turned on for John. So sad. Let's go ahead and fix that. So let's hop into Kaido. And we'll jump into HTTP history. Tell you what, I'm going to go ahead and right-click and hit delete all here so that you guys don't have a bunch of bloat in here that you can see. And I'll go ahead and refresh this page, and we'll get a fresh Kaido instance here. Okay, sometimes that's useful to do. So looking at this match and replace .php file that comes back, we can start investigating the response. So we look right here. All of this is what's called CSS. We can tell that from the style tag. It's just styling for the page, not super interesting. So I'm going to scroll to the bottom of that, and I'm going to start looking at the response. We can see that there's a body tag. We can see a lot of the features that, or a lot of the text that we saw on the page here. And then we can also see this script tag, okay? The script tag is running JavaScript on this page. Now, I'm not sure how much you guys have studied that before in this course, but JavaScript allows you to run dynamic code on a specific page in the browser. Everything else is sort of markup. This is static, right? It's just saying, hey, display it like this, make it look like this. JavaScript allows you to do stuff where you click buttons and things dynamically change, okay? So let's take a look at the code we're seeing here. Well, first we see the initialization of the user object, okay? And we can see the name is John, the role is basic, and the feature flags are empty. So this is very similar to what we're seeing in the UI, right? If we jump back to the UI, name, role, no feature flags, okay? So we're starting to think, hey, maybe this is what is controlling them, okay? Then we see some checks. We see, hey, is the current user's role in admin? If it is, display admin UI. That sounds interesting. That sounds like something we want. We also see check feature flags. Okay, where's that function? Let's keep scrolling around. Okay, we've got check feature flags down here. Does the user have the bouncy ball feature? If so, create the bouncy ball. Does the user have the sparkle background feature? If so, enable the sparkle background. Those are features that we could potentially try to get at and try to access, even though we don't have the permissions to do so. So let's go ahead and try to figure out exactly how that works. So let's try to simulate those states. So we can see right here, or our assumption looking at this is that this is what controls all of this, right? This is the initialization of the data in this JSON object right here, okay? So, and this is a gotcha. I want to make sure you guys pay attention here, okay? Sometimes you need to press the raw button here, because pretty, it displays things a little bit differently. It makes it a little bit prettier. If we press raw, we can come down here and we can see, okay, there is still a space between this and this right here. Sometimes there's not a space, and that will make your match and replace rule bad. So when you're making your match and replace rules, the best technique is to go ahead and select raw and then do it based off of that, okay? So the one, I don't know about you, Nagli, but the one that I'm most interested in emulating is like the admin functionality, right? That seems most interesting. So let's go ahead and build a match and replace rule to tell the browser that, hey, actually the server said we're an admin. So why don't you show us that admin UI? Okay. I'm going to have to edit that out. My throat is getting a little scratchy. Okay, the way we do that is we take the portion that we'd like to match and replace and we copy it. So let's go ahead and select this right here. I'm just going to copy it to my clipboard, and then I'm going to head to the match and replace interface. Okay, we're going to press create new rule. You can see it's not enabled over here, right? So we're going to enable it when we're done, or we can enable it now, whatever. And we're going to select the response body as the place where we'd like to do the match and replace. You can see back here that this is the response body, right? So we're going to want to do the match and replace inside that response body. We're going to do just a basic string for the matcher, and we're going to paste in what we wanted to match, and we're going to do a basic string for the replacer. And instead of admin, we're going to put instead of basic, we're going to put the role admin, okay? We don't have any conditions for this, and we'll press save or update, okay? If we want to, we can come and change the rule. Maybe let's say make basic user admin. Typoed something there. And press update. Okay, now we've got a representation of the rule. We can also test this. So let's go ahead and go back and just grab this portion of the response that we want to test here. Let's just grab, maybe this. Put it into match and replace, and we'll just drop it in here and press test, okay? And you can see right here that the role before was basic, but now the role is admin. That's how we know that it worked, okay? Perfect. So this is working properly. Let's go back. We've got it turned on. You can see it in active rules. Let's go back and try it out, okay? So we go back to our lab right here. We're going to refresh. And whoa, check that out. We got a new button. And we are the role admin, okay? And so if we click now this is a very important thing, guys. So please listen carefully here. Even if you've gone to this point, you have not found a vulnerability yet, because all you're doing is manipulating in your browser, right? You're not doing anything that you don't already have control over. Your browser is a program that runs on your computer. You can say, I'm super admin of the world on your own browser, and no one cares, okay? This is a tool for you to get access to stuff like this button, okay? So let's check what happens when we click this button. So we click Do Admin Actions. It says, congrats, you've done admin things. But if we look at the requests that are coming through, we can see that there's a new request that's coming through, and it says, get super secret admin stuff, right? And we can see the response is actually 200 okay. And it says, congrats, you've done admin things, okay? What will happen, I'm just going to caution you now, what will happen a lot of time is you're going to press the button and you're going to be like, come on, 200, and you're going to get a 403, which is forbidden, okay? And that means that they implemented their controls correctly and there's no vulnerability here. But only when you're able to trigger something that you shouldn't have been able to do, and you're able to do that successfully with an HTTP request, that is when a vulnerability occurs. So please do not go report, I'm able to see the admin UI by doing match and replace. That's not a real vulnerability. The vulnerability occurs when the server actually shows you something that you're not supposed to see, okay? So hopefully that helps clarifying that a little bit. If we wanted to, we could go back in here. I'm not going to go ahead and take the time to do it now, but you could go and add the various feature flags, bouncy ball and sparkle background, right? You could add these into this feature flags list right here. Okay, so I'm going to leave that as an extra exercise to you guys, the listeners, to go ahead and add those in and see my beautiful CSS stylings of a bouncy ball and the sparkle background. Nagli, any comments on all this before we move to the next section?
Yeah, so that's a one point. Everything, the root cause of the issue is that there are API endpoints of administrator that are not enforcing authentication, right, for admin. We, by changing our match and replace and simulating us being admins, we see a lot more functionality, and then it gives us the opportunity to see if there's anything misconfigured that we couldn't see before. But the root cause was always like not us becoming admin, it's the actual endpoints are not enforcing the authentication or permissions in the right way.
Absolutely.
That's a good point, yeah.
Very important distinction there. All right, let's get back to the prez. All right, we're back in the presentation. Here is a very quick representation of the solution to this lab. If you want to take a peek, you can see the bottom right-hand square actually also shows how to put the sparkle background on. So feel free to test that on your own devices. All right, that is a wrap for part 2, just sort of getting familiar with the core pieces of Kaido. If you watch this a couple times and you're feeling comfortable with all of these tools, congratulations, you're kind of a boss now. And this is, if you're comfortable with these tools, you are really far along on your way to becoming a good bug bounty hunter, okay? So congratulations. Give yourself a little pat on the back. I'm kind of sore. I can't even really reach my back right now. But congratulations, you made it. So this next section, we're going to move into Kaido plugins, and we're going to go from there. Nagli, you got any thoughts before we jump in?
Yes, I think we literally taught now the way from just seeing websites, they don't know what they're doing, to actually hack websites. Like everyone can start hacking now. This is from this part, and it's just enhancing our experience with community-led work, so we can find bugs easier or even more bugs we didn't think about.
Absolutely. Yeah. So that's a great point, Nagli. The tools that you have so far, you are completely well-equipped to go hack. Okay. Everything after this is just, icing on the cake, cherry on top. Let's check it out. All right. Alrighty, let's jump right into it. So plugins in Kaido are awesome. The plugin ecosystem is great. There's tons of developers actively working on really cool plugins that will enhance your workflow, reduce friction, and do things for you automatically, okay? The way that you can access plugins is by the plugins tab on the left-hand side, and when you go there, you'll see something kind of like what's on the screen right now. One thing that I really want to make sure you do is you'll see down at the bottom where I've selected number 1, you must check that little box, because what it's going to happen is when you install a plugin, you are giving the developer of that plugin the ability to hack your computer. Okay, so you are taking on that responsibility as a person that's installing a plugin, to make sure that you know what you're doing. Okay, but guys, it's pretty chill. Okay, so chill out. It's not a big deal. For example, I'm going to give you a couple plugins you can definitely trust because they're written by yours truly and a couple close friends. And you can utilize those and get started with plugins in Kaido. So we already talked about number 1. Number 2, that's how you install a plugin. You can search up at number 3 there. And you can also install a plugin directly from source. Okay, so if you're maybe the skeptical type about security, you can go on GitHub. All of the plugins have GitHub source code available. And you can download the source code, install it directly using the install package with the zip file, and run it that way. Or you can install it from the Kaido store. If you ever want to uninstall a plugin, you go to the installed tab, which you can see up there at number 5, and click uninstall. So let's go ahead and take a look at 4 plugins that I love, and we'll show you how those can really enhance your workflow. The 4 plugins are Shift, Drop, Notes++, and Param Finder. Okay, Shift is a cursor-like AI integration for Kaido. For those of you that aren't familiar with Cursor, it is essentially a tool where anywhere in Kaido, you can press Control-Shift-K, and it will pop up a little box. You can describe what you want to happen, and the AI will take those actions for you. It's gonna be awesome. I'll show it to you. It's great. There's Drop, which will cover that enables collaboration, Notes++, organization, taking really high quality notes, and then Param Finder, which we'll use to brute force HTTP parameters. So let's jump right into it. So this is Shift. You install it in the in this plugin store, and it will give you access to this little box. Okay, this little box will allow you to just write in plain text exactly what you want to do. Right here, I've written create a match and replace rule to turn on this admin functionality. Okay, so it knows what you're looking at on the screen, and it knows what you have highlighted in text, so it can make context-aware decisions. It also has access to all of the data that's on the current page. So if you're in, replay, it can read the request and the response. Same for HTTP history. It knows what workflows you have available, what match replace rules exist, what filters there are, and it can, add, update, replace those various sections of the Kaido app. Now, you'll also see at the left-hand side of that little box, you can select an LLM model you want to use. We utilize OpenRouter for this, so you'll need to go and register for an OpenRouter API key, and it uses your own API keys. We don't have any introspection into any of this, okay? So you're just using very, very trusted providers like the LLMs themselves and OpenRouter, okay? Very state-of-the-art stuff here, secure and privacy aware. And then you can see once you submit that by pressing enter, the result will be the match and replace rule has been created and it took the action on your behalf. Super nice. Makes doing things a lot quicker and easier, especially if you don't know how to do it in the beginning. Okay, so that's Shift. There's also another piece of Shift that we're working on right now called Shift Agents. Okay, this will allow you to create micro agents inside of Kaido that control Kaido for you. So you can either store them in a gist or in a directly in Kaido here by providing a title and content. You write down all of the knowledge that this agent needs to know, and then what you do is you delegate a Kaido tab, a replay tab to it, and it will go ahead and perform actions on your behalf, modifying the request, looking at the response, making decisions in conjunction with that system prompt that you provided with it. Super duper helpful. So here's an example of what that looks like. I've delegated one of my tabs to it, and you can see right here that it was able to successfully exploit an XSS vulnerability on my proof of concept website. Pretty cool. Let me see. I will say I didn't put it in a slide here. The way that you trigger this is the agent button up at the top left-hand corner of your replay environment. So definitely use that whenever you're trying out Shift. Okay, so here's what we're going to do. The lab for Shift is going to be the same lab from before, the match and replace lab, but we're going to use Shift to make the match and replace rule, so we don't have to do it manually. let's go ahead and jump right into that. I will say, first, you do have to set up Shift. That's not something we're going to cover here. And here's how you do that. You go to Open Router and you create an account. You load a little bit of money in there to pay for the requests. You create an API key, and then you go to the Shift tab, which is at the left-hand side after you've installed Shift. You go to the Settings tab and put your Open Router API key in there. Once you've got it in there, then all of the AI-powered magic starts happening. Okay, so do that, and I'll show you how to use it to make these match and replace rules. And once again, you can find the labs for this at labs.kai.do. All right, let's jump to the labs. All right, here we are back in the lab. We're going to go ahead and open up the match and replace lab again, and I've disabled my match and replace rules from before, so it's showing me as a basic user currently. Let's jump over to Kaido. You can see that I disabled that match and replace rule, right? I can turn those and toggle that on and off right here. But we're going to go ahead and have the AI make that match and replace rule this time, okay? So here's our match and replace request right here. We scroll down to the spot where we were before, where we're looking at the JSON, and we realize, okay, we need to make a match and replace rule to set my role to admin, okay? So let's go ahead and select that text. Once again, the AI is aware of what you've selected, right? And we'll press Control-Shift-K. Boom, there's the magic little box, okay? We've already set up in our settings, the Open Router API key. So if you don't have that, take the time now to do that. But here we go, magic little box. You can type your query here. I actually already typed my query, so I'm just going to press the up button, which will allow me to access history within here. And I can press this little button right here, or I can press enter, right? So what I've instructed the AI to do is generate a match and replace rule. You can drag this around if you need to see stuff, right? Generate a match and replace rule to turn on all features and make the role admin. Well, how does it know what all features are? Well, like I said, the AI actually has access to the context of the request and the response. So it's going to figure out what the feature flags are, and turn them on. Pretty sick. Let's give it a shot. So we press enter. It starts processing there, and whoa, we can see a match and replace rule created. Let's go check out what it is. All right, I'm gonna jump in here. Here we go, right here. So we can see a little bit more of a complex match and replace rule created here, right? It's utilizing regex. It's saying, hey, let's grab any role and any defined feature flags, and we're just going to replace it with this. Okay, let's maybe the AI got it right, maybe it didn't. I guess we'll see. I will disclaim, sometimes it doesn't get it right, and that's a part of using AI in these sort of circumstances. But let's grab response and let's test it out. Whoa, check this out! It nailed it, first shot, right? Admin is the role, and we've added the correct feature flags in here. Let's go ahead and go back to the application, see how it looks. Whoa, we got the bouncy ball on the screen. We got the sparkle background. We're the admin. Good feels right there. All right, thanks, Shift. That was easy. So hopefully that gives you a little bit of an idea of how to use this stuff. Nagli, you got to say you're kind of impressed, right? That was pretty cool, right?
All thanks to AI, we can see the CSS finally. No, but yeah, the way I see it also, like AI is super powerful to augment us and work together with it, right? Instead of this taking for us 2 minutes, 3 minutes, could take us 5 seconds. So yeah, really try to use AI wherever we can possible to make some repetitive tasks easier. It's the way to go.
Yeah, I think a lot of people are skeptical of using AI in your hacking as well. So one of the cool things that we're pushing for with Kaido is, okay, maybe we're not having the AI do the hacking. We're having it help us configure our tools, right? So that's a pretty benign use of the AI, in my opinion. All right, cool. Let's jump back to the presentation. All right, sweet. That was much easier. As we can see here, actually, I prompted it a little bit more granularly in the solution slide that I have here, but we didn't really even need that. We could just say, hey, make the role admin, turn on all the features, right? Pretty cool. All right, that's Shift. Definitely go play with it. Go create a Shift agent as well. Those things are super cool. Up next is Drop, written by who else? Yours truly, and the Kaido team. And this enables really easy collaboration within Kaido. So let's take a peek, okay? So the vision behind Drop is, wouldn't it be cool if I didn't have to send Nagli the HTTP request that I was talking about? I could just, click a button within Kaido, and my instance is synced with his instance, and he's got the request at the tip of his fingers. Okay, so that's why we built drop. So what you'll see here is the settings page for drop. You'll get a share code in there, which is based off of a PGP public key, which is a very secure and type of encryption. It's been used for a very long period of time. And you take that share code and you share it to your friend. That's how you sync the instance. You just paste it into that box and it'll add your friend to your friend list or whatever. Okay. Then throughout the app, you'll see these little drop to buttons. Okay. Like the one you see up at the top right. You can select the friend you want to drop it to, and that item will, object whatever it is, could be a replay request, could be a filter, could be whatever, that will be sent to your friend. Boom. Okay. And you'll see down at the bottom there what it looks like when your friend gets a message back. You can see there's a drop from Justin Gardner. Here's the specific request. You can claim or delete it either way. And this is super helpful for very closely collaborating with other hackers. It allows you to transfer these requests back and forth, keeps a log of them, in your replay collections, and makes it a lot more seamless than trying to copy and paste a large request into, Discord or Slack or whatever your chosen medium is for communication. So let's go ahead and jump into a lab with drop. Okay. The goal this time is to add a friend's share code and drop a request to a friend. Let's do it. All right, y'all, here we are. We've installed drop. If you don't know how to do that, once again, it's plugins here, and then you find drop, boom, install, okay? And it'll auto-generate you a key that you can use to pass stuff to your friends. So let's go into the drop interface here, and we can see my share code. This is a burner share code. Please do not spam this share code with a bunch of requests that you want me to look at, okay? One of the things you can also notice is that we are our own friend by default. So that's kind of cool because we can just drop stuff to ourselves and experiment with it. So if your friend wants to send you something, then you just press this copy button, you paste them the share code, and they can send it directly to you. You can also regenerate your share code if you'd like to, so that if somebody gets access to your share code that you don't want, you can regenerate it so it's not linked anymore. There's also some custom settings here. If you want to set up your own, enterprise version of drop, you can do that. We've open sourced everything. You'll just need to set up a custom server configuration here. You also may want to export your PGP key and be able to re-import it just in case your Kaido data gets lost or something, and all of your friends have your PGP key, then you don't have to redo the setup again. Okay, so for now, I'll just give an example of what it looks like to share a request. Okay, so I'm going to grab, actually, I don't need to do that because I'm already my own friend. I'll navigate over to replay, and you'll see these drop to buttons that are throughout the app. Okay, so I'm just going to select the one up at the top right here, and I'm going to drop to myself. So we'll go ahead and let that replay come through. Boom, there it is. And then we can press claim, and look, now we've got an identical request in our drops collection right here. And we can use that and collaborate with our friend. Pretty awesome. Pretty cool stuff. I hope you guys use it. That's how you set it all up. Get your friends to do it as well. And collaboration will be so much more seamless. It's been really great in the competitions that I've been working in with Nagli and with some of my other friends. So I definitely recommend it. Any thoughts on that lab, Nagli?
Nope. Straightforward.
All right, let's do it. Let's push through. All right, y'all, here we are back in the presentation. Up next is the Notes++ plugin. Let's go ahead and take a peek. As you might have imagined, this is a note-taking plugin. The reason it's really nice is it's integrated into Kaido in lots of different ways. One, it's directly in Kaido on the left-hand side, but also it will allow you to take requests that are in replay and link them within your notes. There's also some really nice keyboard shortcuts. Windows Shift N creates a floating note modal. A floating note modal. I flipped that around, didn't I? And attach the current replay tab. And then also you've got your Control Shift R, which will send the data that you've selected right into your note. So it makes it really, really easy for you to take notes, especially if you're not a big notes person. This is a great way to get some stuff stored away for you to review later. Okay. So we've got a lab associated with this as well. Once again, go download it from the Kaido store. And this time, all we're going to do is just create a markdown note using Notes++. So let's jump to the lab. All right, guys, here we are in the lab.
you notice we're kind of big on labs, right? Labs are very important for you to get hands-on experience with the tool, right? We don't want you to just be watching this presentation. If you're just watching this presentation, you need to go back and do the labs, okay? You're not going to become a hacker by just watching this. You need to get your hands on the tool. You need to get your hands dirty, okay? So now we're going to do a lab on Notes++. I've gone ahead and installed it from the plugin store. Once again, you can do that by plugins, searching for Note++ here, and pressing install. I've got it already. Here's the interface where you can start creating notes. So if I press this little pencil right here, ooh, I've got a new note. I'll call it maybe, SEP 9 hacking session or something like that, right? And I can add whatever notes I want here, okay? That's great. And this is a helpful interface. You can come back and forth to it, from replay to notes and add whatever you want. But the thing that I love the most, y'all, is that floating modal that I told you about in the presentation. So let's go ahead and do that now. Here we are within replay. We want to take a note of this IDOR vulnerability that we found. We press Windows Shift N and it pops up our little note-taking modal, okay? It's selected the currently open note that we've got. It's attaching the current replay context, and we can say, yep, this one is vuln for sure, okay? Gotta report it, okay? We'll press enter. Note successfully updated. Great, we didn't even need to leave replay for that. We go to our notes, and look at this. Look at this beautiful representation, Nagli. Isn't this sick? We can see the note right here. We can see the request in beautiful formatting. And if we want to, we can double click on it, and it jumps right back into replay, right where we left off. Super easy to jump right back into what you were doing when you made the note. Love it. I use it all the time. It's an excellent, excellent plugin. All right, that's what we had for Notes++. Let's get back to the presentation.
All right, hackers, that was Notes++. Now we're on to the last plugin in our set today, which is Param Finder. Param Finder was written by Bebix, and the goal of this plugin is to brute force HTTP parameters. Okay, you guys remember HTTP parameters, right? That's like that user_ID thing from the IDOR lab. That's a parameter. And sometimes there are hidden parameters on HTTP requests that don't show up, in the request that we're using. So we want to be able to find those and use those to control the application. So let's take a look about how that works. This slide is a little busy. I know that it's a little busy, but I wanted to show you how exactly we utilize this. So typically from like replay or HTTP history, we right-click and go to the plugin section, and we select one of these four options: Param Finder Query, Param Finder Body, Param Finder Header, okay? We could also do advanced. We're not going to cover that today. Typically, it's one of these three. So you're looking to find new parameters in the query, the body, or the headers, okay? That will kick off a scan that will start brute forcing and trying a ton of different types of parameters, thousands and thousands and thousands. You can see right here, 33,920 attempted. And it found two that create a different result: name and source. And we can see that source is really helpful in this scenario because it allows us to control the source of an iframe. Very useful. You also see the findings in the findings pane within Param Finder, and it shows why it detected this. There's an anomaly in the reflection count. Okay, that means that they provided something in the source parameter here, and then they noticed that it was also in the response, and that was what triggered the Param Finder to find this HTTP request. Okay, so that's kind of how you use Param Finder, one of the best plugins out there on the store. We don't have a lab for this one, so go ahead and install it yourself. Give it a shot. It will help you find a lot of vulnerabilities. I've used it many, many times myself and have made thousands and thousands of dollars off of that one extension. Thank you, Bebix. Thank you, Bebix. All right, well, that's the end of our plugins portion. Let's go ahead and get into Hack the Planet. Nagli, as we transition into Hack the Planet here, any comments?
No, it was great. We really went into, I think it chose for us almost 3 hours, probably like 2 hours, more than 2 hours of really nice content. You don't need to go over it once. We will have supporting materials in the course website. And really, like, everyone is excited now what kind of superpowers you taught them in the last 2 hours. Like, what what's the next step for them. I know what's the next chapter for them in the course. It's seeing some real-world hacks that I did, which are super simple and super critical, so they can do it themselves. But I'm really like, okay, you just finished it. You just taught someone all of this content. What are they doing now after all of this?
Let's cover that. So you've got your tool belt, you've got Shift, you've got Drop, you got Notes++, you got Param Finder. You know how to use Replay, Automate, HTTP History, Search, Match and Replace. Frick, we know how to use Match and Replace. I love it. You are really well equipped to go do some hacking. So let's go hack the planet, guys. Here is how you get started. You pick one of these 4 bug bounty platforms: HackerOne, Bugcrowd, Yes We Hack, Integrity. Okay? You register, you sign up for an account, you pick a program. They have sometimes it's called opportunities, sometimes it's called programs, sometimes it's called whatever. You got to, find it out for the specific sites. Find a website you can hack and read the policy page on how to do that. So here's an example right here. This is from HackerOne. The U.S. Department of Defense runs a vulnerability disclosure program. So you're not going to get a bounty for this, but they will allow you to hack on them. And they say the scope for that, when you read the policy, is publicly accessible information systems, web property, data owned, operated, or controlled by the DoD. Massive, massive scope. You can hack anything DoD, right? This is what that gives you the right to do. So that's a great place to start. A lot of people do start with DoD, but pick your platform, right? HackerOne, Bugcrowd, Integrity, Yes We Hack of choice. Pick your program and just get started. Even if you don't know what you're doing, just get started and start parsing through HTTP requests. It's going to take a couple hundred HTTP requests before you feel really confident in it. Okay, so you got to get rolling. Another option is to not use the platform and go directly to some companies that run their own programs. For example, Wiz runs their own bug bounty program, and that's the scope right there, which I've specified. So you can also feel free to hack on Wiz if you'd like. Guys, it is important now that you take this step. Okay, you've learned about Kaido, you've learned about how to do bug bounty, you've learned about these plugins, you've got your hands dirty. Now you just got to get out there and do it, and you're gonna have to do it for a lot longer than you thought you would. I guarantee. But if you keep pushing, you're gonna be successful. Find some vulnerabilities, get some bounties, and guys, it is a blast. So I hope you enjoy it. If you want, I'm available for questions. You can jump into the Kaido Discord. The link's on the screen. You can jump into the CTBB Discord. That's the Critical Thinking Bug Bounty Podcast Discord. You can drop your questions and queries in there. We'll try to help you out. And yeah, get hacking, you guys.
Yeah, I also emphasize it a lot on the foundation part, like join a lot of communities, Discord, X, LinkedIn, follow people who know what they're doing, sharing write-ups, activity, HackerOne, like absorb all the content, all bug bounty content at all times, like when you scroll over X or something, even Instagram. I don't know if there is quality bug bounty content on Instagram, but yeah, just join these communities and always like, if you see a new idea, maybe it sparks interest in your target of choice, and then you can just apply it right away with the skills you learned today. And I'm also very excited for the next chapter where we show real world hacks that I did. And also, Justin, thank you very much for taking the time and doing all of this with us.
Of course.
I hope it will help more people score their first bounty.
Absolutely. Thanks for having me on, Nagli.
Thank you.
Hey everyone, super excited to welcome you all to the final chapter of our Bug Bounty Masterclass. In this one, and I think this is the best chapter out of them all, we are going to really see real-world hacks that I performed in the past couple of years. I've picked 9 very specified use cases where I will show you exactly how I hacked different companies, how they paid me bounties, how I wrote the report, what was the impact, and essentially I want to really give you the rationale, how I found the bug, how you could practically find it yourself with the terminal or with a web proxy, and the whole process of really discovering bugs and how were they even introduced by the affected companies. So we have 9 use cases, and I hope that in the next hour we are going to dive in, and you can pause the video whenever you'd like and just learn. And my goal is that after your video, you will get enough motivation to find your first bug in any bug bounty program out there. So without further ado, let's get started with the first use case. So around January of last year, I was able to discover and expose DeepSeek database that leaks sensitive information, including chat history.
So if you all remember, around the end of last year, DeepSeek really rose to the attention of X, and in general, they developed a very capable AI model with a fraction of the cost of OpenAI and others, which brought great results. So first of all, it was the baseline model, DeepSeek V3. Then it was the reasoning model, which really compared very well with O1 at the time when OpenAI released. Then NVIDIA stock really crashed 17% with the news of DeepSeek and with the launch of their models. And then there were like news that OpenAI and Microsoft thought that maybe they distilled some of their data. In general, it caught our attention. Every time there's new technology, new domain, I really want to see if there's anything exposed there that we might find. So on the same day, on the 29th of January, I was able to discover this exposure, and I will show you exactly how I did it. So this is all we had, right? DeepSeek were launched. We have a root domain, deepseek.com, which powers DeepSeek. It's their main website. So what do we as an attackers do once we have a root domain? Root domain is usually what we have as a beginning for every company around the world, google.com, in general. What do I do right now? We're doing Reconnaissance now. As an attacker, I want to find all the publicly facing assets of DeepSeek, not only their main domain, with the goal of finding some development instances out there that were left open and might expose sensitive data. So the first thing we want to do, as I explained in the third chapter as well in this course, is to find all the subdomains. So we have deepseek.com, and now we want to discover the subdomains. So let's do it practically and very easy in the terminal right now. So I open a new terminal, and I'm going to use a tool named Subfinder pretty easily. So first, let me create a new directory for DeepSeek. So we can hack DeepSeek now. Let me go into the directory with cd. Now, the first thing that I want to do when I see a new company, let's find the subdomains. Let's see what the internet knows about the company. So I will do this following command, subfinder-d deepseek.com, and I want to save the results also so I can do later steps about that. I explained about Recon in the third chapter, but anyway, I will also show it here. So DeepSeek to resolve. In this case, this is also what I did when I hacked DeepSeek. We did the first step of seeing what public asset they have. So if we can look at DeepSeek, let's see how many lines. It found 43 different unique domains out there that belong to DeepSeek. This is the first step. Now we have a list of 43 domains, but not all of them are public. Some of them might be private, some of them might be dead already. So now we want to see what actually has a record behind it, the internet, and is actually publicly facing. So the next step for me will be to resolve the domains, to see if they have any record behind them. So I will do pure DNS, which is a tool I use, resolve, and then let's save the results to a file named DeepSeek resolved. Let's let it run. It should be pretty quick. Perfect. Let's clear the screen. Let's see what we have in a directory. So after I run these first two scripts, we see that there are 32 different names of DeepSeek that have actually an IP or a server behind them, out of the 40-something we had at first. So now we want to probe for public exposure. I want to see which ones of the domains is actually publicly facing. So for that, we use a tool named HTTPX. And I'm just doing cat, which like read the file contents to HTTPX. I want to save the title, the status code, the location of all the domains, and I want to save them on a file named DeepSeek HTTP metadata. Now it runs pretty quickly, but what we want to find here is maybe more domains that are not really exposed. They didn't launch anything about them, but they might be part of their internal infrastructure. So of course, I'm recording it today in October. It's been almost a year, and the vulnerability was fixed long ago. But when I did this step of finding the HTTP servers, everything seemed pretty usual. Like we see here, we have the chat instance, we have documentation, we have the main domain, www.deepseek.com. I didn't see anything out of the ordinary. But the next step, which we should do, is do port scan. By doing port scan, we might find some HTTP servers or web applications that are exposed on unusual ports, not on the normal port of 443, that might expose sensitive systems. So this is what I did like when I did last time. I did Subfinder, I found these results. Then I did HTTPX, I found these results. And then I did port scan check, and I found this port 9000, which was exposed and pretty interesting. So because we won't see it now, I actually prepared a lab which simulates this exact use case. So now we want to do port scan. We want to see if there's any publicly facing services that are exposed on unusual ports. So what I will do now, I will take the resolved list of all the subdomains. I'm using a tool called Nabu. And now I want to scan for different ports, not only port 443. So for example, let's scan for port 9000. You can also have an option to scan for the top 100 ports. So I'm doing this command now. Let's wait for it to run. Basically what it tries now, for every subdomain that we discovered on Bug Bounty Masterclass, it checks if port 9000 is open. Here we see it's almost open like on all the ports, but for the sake of the example, we want to check if deepleak.bugbountymasterclass.com port 9000. So what we want to do now is to pipe it. So not only to discover the ports, but to see if there's any web services behind them. So I will do HTTPX on the results, like I pipe for the previous results to the new ones. I will do status code, location, title, and then I will save it on full HTTP metadata. So here, that's how we have a complete file with the port scan results and the normal ports. We see that only one asset with port 9000 actually exposes something to the internet. So let's navigate to it and see what actually exposed. Perfect. This is exactly what I saw when I tried to hack DeepSeek. I found this port 9000. Then I got an alert for a weird port which actually exposes a service. And now it tells you, hey, there is port 9000 exposed. Try port 8123 for HTTP. This is what I did. And then I was just facing this weird ClickHouse database for internal operations, which was publicly exposed and actually belongs to DeepSeek. So the process here is a process they automate, and it's repeatable for any target. You take one root domain, you find the subdomains, you check what is actually alive, you check what is publicly facing on the normal ports and on unusual ports, and then you just try to hack yourself and see if there's anything like which shouldn't be publicly exposed, but it is publicly exposed. Then I did show databases, and we could see that it's actually publicly facing without any authentication. But it could be even easier than that. You don't even need to do the manual part that I showed you now. You can just use a tool called Nuclei to do this kind of detections. So let me show you how it works. There are a couple of templates that you can scan, and they basically check, hey, can you check if this server is vulnerable to this vulnerability? So what I do every time, I find all the subdomains, all the public servers, and I check them for common misconfigurations that I know are out there or publicly facing or relevant to specific technologies. So what I want to do here is to use the tool Nuclei and check for any misconfiguration that affects ClickHouse databases, which is specifically what the database that DeepSeek exposed. So let me, I messed up my command, I forgot to do echo, so let's do it again. I need to echo the file and then run Nuclei. Perfect, so what Nuclei does, it tries to run all the dedicated checks that exist in the open source repository for ClickHouse, and it tries to find if there's any misconfigurations exposed on them. So here on the port 9000, it actually didn't find any misconfiguration, but let's check for port 8123. And perfect, and this is what I actually saw when I hacked DeepSeek, and even whenever I find these alerts, I also send it to them, to myself. You can send it to his email, with Slack, with a notification to your phone, to Discord. And this is what I saw basically in the whole process in an automated way. Found all the assets, checked what's public, checked what's alive, and then for every technology that I detected, like ClickHouse, I tried all the relevant Nuclei exploitation templates for this specific technology. In this case, it actually tells you, hey, the ClickHouse portal that you found is unauthenticated, and you can query its databases. If you wanted to know how to detect the technology as well before you feed it to Nuclei, instead of running 8,000 templates, so it will only know to run these specific suite templates, you could add to the HTTPX command the flag tech detect. And when you do that, it tries to detect the technology. In this case, it didn't find it, but usually it does find like specific technologies like VPNs, web servers, and then you can only scan for these specific web servers and technologies. So this is like a lab that I vibe coded just to simulate to you how I found it, because it's fixed for a long time. So it's not exactly as I found it myself, but it really gives you the opportunity to follow along and see if you're on the right track. And this is the alert that I received on my Slack right after I had lunch. And you could see I found a ClickHouse unauthenticated database. And this is what really caught me to try and find the vulnerability. I navigated to the website. I saw the databases. Then from there, it was pretty easy. Like I saw this unique database. I never had ClickHouse before. I never saw it. I just asked Google or ChatGPT, hey, how do I list tables from ClickHouse? And then it gave me this command. Then I saw the databases. Then I tried to look more into the data to see if there's anything more interesting, and then I found the chat history. So even every time, like even if I'm doing it for almost 5 years, I will find some place where I'm getting stuck, or I need more information, just using AI, the latest models will be very helpful to help you hack deeper. Why were they even exposed? Like, why would, you'd expect them to not have this issue. But actually, it's not only DeepSeek issue. Almost every company around the world make this kind of exposures. So if you think about it, they have engineers, AI engineers, super smart. They have internal network where they store logs about the system so they can make them better, see if they're actually functioning, or if they actually work. And then they have internal host names for them, like dev.deepseek or host.deepseek. This is how they navigate to their websites when they hosted them internally. Now, when you host internal stuff, usually you don't put passwords, right? Because you want other people to navigate to it. It's internal. No one can ever access it, right? But all it takes for you to become vulnerable is just one misconfigured WAF rule or network rule. Let's say someone changed the setting that he didn't even know you have this system, and he made it publicly facing, then it's game over. So it shows you the game of defense in depth. Like, you don't want to put this kind of passwordless instances even internally, because attackers can either, like bug bounty hunters, mistakes like this always happen. If you monitor this asset, you will find these exposures. Or, sometimes threat actors gain access to your network, then they can pivot. But in general, this is what I think happens most of these use cases on the internal portals. Someone just makes a very small mistake that makes it publicly accessible, then it's game over and everything is out in the open for you. This is just a process to sum it up, and it affects any company that you'd like. You want to discover the subdomains. You want to find the externally exposed services. You want to identify anomalies, scan with nuclei, automated exploitations. You do the exploitation validation, and then you do responsible disclosure. So this is what I did here. Essentially, this whole process, the script, it took like 10 minutes, and I found a vulnerability right in my Slack. Super easy, super simple, and you can develop it yourself for any bug bounty program that you hack. And this is how I actually reported it to them, just so you could see. I wrote critical exposure, DeepSeek exposes sensitive data. I took the image that I found in the documentation. I told them that I found a significant exposure in Wednesday, Jan 29. I gave them the POC, showing them, like, I didn't send any PII or anything intrusive, just showed them, hey, this is vulnerable. This is the proof of concept. And then they picked it up pretty fast and actually told us, I think they fixed it in like 1 hour and a half, 1 hour. Then they told us the next day that they used our input to fix the issue. This is like an example of, it's not a regular bug bounty program. It was a normal service out of the internet. They were kind enough to really accept the vulnerability. And our goal is, of course, not to do anything like intrusive or threat actor. It's just to make sure that the products we use and the public use are a little bit more safe and sound. So that's it for the first use case, and let's dive into the second one very shortly. So what exactly happened here? And for this one, I have a whole lab that I set up, so it will be easier to follow. Okay, so imagine this is the airline, airlines.bugbountymasterclass.com. So ignore the root domain, imagine it's airlines.com. So I saw this website, I checked my booking, I wanted to manage it, see if I can check in, change my seat, and so on. And along the way, I did exactly what I did in the past video, just wanted to check all the subdomains of airlines, like see if they have any subdomains exposed, maybe APIs and so on. So first step, just to see all the public subdomains of this airline. So in this case, it's hosted on our main website. I will do that. Let's wait for it to run a couple of seconds. Okay, so we see we have airlines.bugbountymasterclass.com, which is fine. But once I dig deeper, you see that we also have another subdomain here, which was api.airlines.bugbountymasterclass.com. So let's take these two domains. Let me put them in a file, airlines.com. Okay, let's say that we check they're publicly facing. I will run HTTPX. And then I will save them in HTTP metadata, as I always do. Okay, perfect. And now another file that I always save is, here we have metadata that will help us. Let's say there are thousands of domains. You want to see only the ones that return 200. You want to navigate by the title if you see anything like dev admin instance, so you can navigate right away. But if you want to put it in another tools like Nuclei to check for exposures, you only want the domain without the metadata. So for that, I cut the contents of the HTTP metadata file. I only save the first part before the space, cut df1. And then I save it in another file. I call it HTTP servers to list all the HTTP servers that we have for the airlines company. Now there's a common misconfiguration that happens a lot of time with APIs, and it's when companies expose their Swagger API, basically the API specifications, how they power their whole website. for every domain that I find, when I check what publicly exposed for a company, I check if they expose some of the Swagger API specification. Basically, we might find some endpoints there which are publicly facing unauthenticated wake. To do that, I have a template in Nuclei that checks every HTTP server if they exposed a common path for the Swagger specification. I run this exact command every time, and here we see in action that it found 2 Swagger API commands on the airline's website. Now let's check what's actually inside them. So let me copy and paste it. Just for the sake of the example, if you go to the main domain here, like API Airlines, you see 404 not found, nothing. A lot of people would just give up here. I mean, this website is dead. But always think to yourself, like, there is a reason a website is publicly facing, because if there was no reason, it wouldn't be public. Like, it didn't exist. So also this name is API and it says not found. Okay, maybe the actual data is exposed not on the root of the page, on another path, which is what happened here. So this is Swagger UI. You might find it a lot of times, and it's a trove of sensitive data most of the times. And this is what I saw for this specific airline that I tried to hack. So every time I see this Swagger, I just check a few commands here and see if they are publicly facing or there's authentication. So we can try get bookings, random number, but we see it actually says unauthorized. So it's pretty much like maybe it's dead end and it's all okay and it's correctly configured. But I mean, in Bug Bounty, always challenge stuff and never give up and so on. So I tried all the endpoints or a couple of ones that look interesting to me. And when I did this API get memberships, it literally gave me the whole members of the airline. You could see all the data, tens of thousands or hundreds of thousands of people, their miles when they signed, their last flight, and all the data here, you could literally use the member ID and then fetch even more data from the different endpoints based on email or based on his ID. So basically, this kind of API, this is how I found a massive data exposure on an airline. And it's a mature airline, very old company, and it's pretty simple. And it's not like in a fairy tale, this kind of stuff. It's common, it happens a lot of times. And you just find data, API that are misconfigured. The developers didn't even realize they're publicly exposed. And then basically you just go on from there. So you could use the member you found earlier to find even more data about the user. And you can even update the details of other users here with update member info. You can change an email, take over accounts, and so on. Okay, so to sum up, like what the concept that I wanted to deliver to you is API docs are very important to find. Using Nuclei to discover more endpoints also, and not only misconfigurations. Also, the concept of the domains that have not found or nothing in them doesn't mean it's dead end. Like there could be some stuff exposed on other endpoints that I will show more examples of that in the other sections of this chapter. And basically this is a kind of vulnerability that happens a lot of time, API security testing, just finding the specifications, the internal docs, trying to poke in them a little bit. You don't need to be a mega hacker or know a lot of exploitations. It's as simple as sending requests. And if you need help, you can also ask ChatGPT, Gemini, Anthropic, Grok at all times, that they can simulate the command. So this is for the second use case. I hope you liked it and could incorporate some of the stuff to your own hunting. And now let's jump into the third one together. Hey everyone, welcome to the third use case in the real world hacks chapter. And this one was a pretty critical exposure that I found on HackerOne. And it was a domain registrar data exposure, and it was pretty significant. So this was 2.5 gigabyte database leak. Must-be AI and secret leaks were completely exposed /uploads folder, which bypassed an Okta verification. So it's a little bit bombastic title, but I will go through with our lab very easily here. So this was my report to a redacted bug bounty program. Hey team, like I tried to be nice and chatty. I didn't find a bug on them for a long time, but I was the #1 hacker there for a while. And I told them happy to hunt again. So I was able to identify massive PII leakage of a lot of users by bypassing the Okta verification. Imagine the login page of the company. And I did it using fuzzing, using a tool called FFUF, which is another important concept I want to show you all in this course. And we will just dive into the lab and do this together. So many companies have sensitive systems exposed to the internet. Imagine Shark is a private domain, internal domain. It shows you a login page. Everything is fine. You can't see anything. You have to log in. You have to verify, like it tells you, the user is not assigned to the application. You can't see anything here. But the problem here is that you can't take anything for granted. Because even if the main page tells me I don't have access, maybe if I try other endpoints or other directories, they might be misconfigured and open. And this is what happened here. So in the sake of the example, how I exactly found it, Let's go back to our terminal. Let's create a directory for Shark. I will save the subdomain Reconnaissance file because we did it already. And we know the domain. It's shark.bugbountymasterclass.com. Okay, so we are going to use the tool FFUF to find specific directories or try to find and guess directories on this given domain to see if there's anything exposed beyond the Okta, beyond the login page that might be misconfigured on a different directory. For that, I'm using the FFUF tool, and we specify here the domain on the U parameter. We press on the fuzz. When we specify the keyword fuzz, it tries to put the domains or the words in the word that I specify. So in this example, I'm sending a publicly, like you can search it on Google, one list for all micro.txt. It has 15,000 words. I will show you later how it consists. And it tries every single word from this word list, attaching it to the domain, and checks if anything is publicly facing. So I want to see if there's any status code 200, status code redirect, 301 or 302, which might suggest that there is an exposure of something which is misconfigured. So I'm letting it run now, and you see it's pretty fast. It's sending 1,000 requests every second. So you want to be careful sometimes on targets to see that you don't flood them or maybe do denial of service. But this tool is capable of doing pretty fast requests. So we can see it found the index.html path, and here we see it found the uploads directory, which is pretty interesting. And this is also what I saw when I have this company. It suggests a status code of redirect. It has a status side, which is interesting. So let's see what happens when I navigate to the uploads directory. And here I saw like a trove of Jira stats, which Jira is an internal ticketing tool, which suggested to me that it's pretty interesting. But more interesting was the sharkdb.zip. So when you download this file, I saw a zip file. You open it, you double click it. Then I saw a SQL file with tons of sensitive data, phone numbers, home addresses, credit card information, over 1 million records of many of these company customers and internal support interactions. And this is how easy it was to find. You see a login page, an IDP, even common Okta or like very popular authentication and identity tools. One small trick that I like to do here is that if you try any pass here and it redirects you to the same page of like, hey, you need to log in, it's highly likely it's not misconfigured and it's okay. But if I try another like random word and then it shows me 404, it means I didn't find this directory. It means that there was no authentication enforcement here. So there might be some passes here which are real and publicly facing. So this is how we found the uploads directory, and we were able to really hack this major domain registrar. And just for another example, I wanted to show you how the word list looks like. It's just a list of 15,000 random words, and we really try to find ones that is open and might have sensitive data inside. What I want you to take away from this example is login page doesn't mean it's game over. You could try other passes, see if it's enforced, or there might be some directories or files that leak sensitive data. And the concept of fuzzing, really taking a word list, trying it across an asset, and see if you can find any exposure of sensitive paths or sensitive data along the way. I will leave it to you to look at the database file and find the flag there for the certification. But this concept also shows you like very critical bug, pretty easy. It's also pretty easy to misconfigure when you're a developer. Someone enforces identity on the main page, they think everything is okay, but then there is an exposed directory, which is not okay, and exposes sensitive data. So I hope you enjoyed this third example, and you can incorporate fuzzing in your testing. And now let's jump into the fourth one. Blind cross-site scripting was one of my first bugs that I found a critical bounty for, I think like 4 years ago, $2,500 for this bug. And this issue is pretty common, pretty easy to test, and very critical in this sense. So this is a bug we found last month on blind XSS on a company, which basically, I will explain the logic of blind XSS and how it works. But what happened here is that we put an issue. We left a support ticket in an authenticated portal, and the admin, the support engineers of the company, visited their internal admin page and admin panel that sees all the issues, and we were able to inject a script there that when the administrator visits the page, it sends us an email with all of his cookies, authentication, and we could literally see sensitive data and authenticate as the administrator or as a support engineer to the internal admin portal. And this is an example of cross-site scripting, and I will show just now in the lab how it works. It's pretty easy. This is a simulation of the website that we were hacking. A lot of functionalities, different logistic stuff, but there was also a place to leave your issues. You want to raise support ticket for support. So I will write like, hey everyone, I have an issue, feature request, And every time there's a field insertion in Bug Bounty in general, I try to see if there's HTML injection. I use this payload h1 Nagli h1, close tag h1, and like it's pretty simple. You can also have ChatGPT like of the concepts of HTML injection or cross-site scripting. But I try this payload every time to see if there is a potential for a cross-site scripting vulnerability. Hello, hello, how is it going? So I'm trying something like that. And me as a user, this is what happened. I mean, I don't see actually where it renders, so I need to pray if it worked. But now if I go to the admin perspective, and I go to the issue that I created, you can see that my text was rendered. I mean, it's not similar text like this. It actually rendered the HTML on my page. Because of that, there is high chance that it could also render JavaScript. It could also render a script tag. And using a script tag, we can tell the browser for the admin or for the support engineer when I'm going to this page, hey, this is the script tag, send all your information to Nagli's computer, to Nagli's email, to Nagli's instance. So this is how it looks like. Whenever you see a field or any field that comes to another internal portal probably of different company, always leave your XSS payload. So this is my blind XSS payload. I'm using like js.rip. I mean, I won't give you my own one because you will spam me, but I will do Nagli. Every time I visit a page which might render sensitive data or might evaluate scripts, I'm using my blind XSS payload. And what it does exactly, you submit the issue. As the admin, you navigate to the page. And now that I navigated here, you can see that the page actually rendered the script. And what the script here says is basically send all your information, send all your cookies to Nagli's email. And it's a critical issue at all times because it means that I, as a normal user, could have navigated to this internal admin support portal, see everyone's requests, and really could just do everything here, impersonate the admin, account takeover, and so on. So this is called blind cross-site scripting. It's not that common, but you find it a lot of times on this, like maybe old companies or very gated instances or authentication portals. And I mean, it doesn't cost you anything. You just put a script tag every time you see a support ticket or somewhere it could evaluate. And then one day you wake up either after a flight or in the morning and you see an email that tells you, hey, you just got a blind cross-site scripting alert on this company, and you know that you're expected a big payday and critical bounty. So this one should pay 18,000. My first bug here was 2,500, and I earned, I think, overall over 50,000 just for blind cross-site scripting. It's basically every input form that you have that doesn't restrict you for putting script tags and might be evaluated in an internal portal later on. Just try to put the script tags of blind cross-site scripting and make sure, and you might score a big payday. How do we actually, where is the JavaScript code that sends all the cookies, all the authentication to your own email? So when you do the script src, js.rip.test, for example, it's someone else's instance probably. So when you do that, when the admin navigates to the vulnerable page, it basically navigates here. And in this page, you see all these commands that basically runs in the browser of the admin when he navigates to the page, it evaluates, and then basically it says, hey, take all the data, expose all the secrets, expose all the cookies, send them to my email, and that way you actually get the alert that shows you, hey, I'm inside the admin panel. I can log in as an admin now to this specific company. So this is how it looks like. We just put the domain in a script tag, and then all this code here is rendered in the victim's context, and then you get an alert and probably a big payday. So this is just a small clarification, and now we can jump to the fifth example. Hey everyone, and this is the fifth section on our real-world hacks, and this is one of my favorite bugs. It's subdomain takeovers. I think I got one of my first bounties. It was $2,000 from a crypto company when I took over one of their subdomains. And this is a very interesting use case because it was a root domain takeover. Somehow, by accident, I took over a main domain of a company. Imagine I took over www.google.com. So it was pretty interesting and pretty exciting. I don't always put urgent on my bug bounty reports. Usually you don't do that. But this was pretty urgent because it was a takeover of www.something.com, which is pretty interesting. It was a fintech company. It was 11 p.m., so I hope they were awake. And basically, this is what we saw. There was a subdomain takeover. There is a matcher. This is a bucket, which we saw publicly facing. It says you, hey, this bucket doesn't exist. And what you can do as an attacker, you can just go to AWS, register this bucket with the name www.fintech.net, and then you can host your own content. So I hosted my own content on this major fintech company, and everyone would navigate to the main domain of www.fintech.com. They just saw Nagli, my name, POC. So it was pretty urgent situation because imagine you take over Google and everyone sees your picture or your Twitter or your X account. So what is the concept of doing subdomain takeovers? I will show you now in our lab. I set up this bucket. This is a fake bucket because it's not really a bucket. I just put this on the HTML, but it's for you to experiment with. So the concept here is basically just in a naive level of checking for HTTP subdomain takeovers. Let's create a directory for Bug Bounty Masterclass. Okay, so now we can do one command that will find us all the subdomain takeovers in the HTTP level of any company. So we'll do subfinder masterclass.com. Let's check what is active, pure DNS resolve. Let's do HTTPX, and we want to find the status code. And now I want to only focus on the domains with status code 404. It means that there is no content found, and it's usually the signature that means that there might be a subdomain takeover vulnerability. Now I want to keep only the first part. I don't want to keep the metadata on the domain. I just want to keep the HTTP server that I want to target. And now I can do nuclei and check for all the available takeover templates, detections. So let's do this one command. It uses like 4 tools in the same time. It's piping, so it takes the output of each tool as the input of the next one. And here you can see it took me 5 seconds to find subdomain takeover on our own website, on the lab, and it tells us, hey, there is an AWS bucket takeover here that you can now do and really take over this account and claim it to yourself. So what's the real trick here and what's the juice here? So basically every time you get a new target or a company which might not have bug bounty or is not mature, you run this one time, you will find subdomain takeovers almost certainly if they're a big company. Because it's not really known for security teams, and it's so easy to like use a service, then stop using it, then you might take it over. It's not only for AWS, also for Shopify, for Vercel. So a lot of different services are vulnerable to subdomain takeovers, but AWS bucket is the most common one. But the second caveat here is you find the subdomain takeover, you do it once, but like, why are there so many? How do you find it so many? So this field is very competitive. A lot of the bug bounty hunters out there, they scan millions of domains of bug bounty programs every minute to see if now they are claimable for subdomain takeover. So I used to run in my glory days, let's say a few years ago, I used to have an automation for subdomain takeovers, which every minute and 30 seconds try to check across millions of subdomains. If they are now misconfigured to subdomain takeover, it would then send me an alert to my Slack or Apple Watch, and then it would try to claim it right away from my terminal and not really logging into AWS and claiming it. So this field is super competitive in terms of monitoring your target for subdomain takeovers. But where you might find the chances for you, even if you don't do automation or monitoring, which you can do as well, you can enter the competition, you can just try to find more subdomains than your competition. You can try brute forcing more subdomains, or you could try to use paid resources, which might see more subdomains. You can monitor daily maybe for more subdomains. But in general, this concept of subdomain takeovers is very frequent to scan a company, see that they are not vulnerable, and then just monitor, and suddenly they even make their main domain exposed. So what happened here, it was www was hosted on WordPress, and then the WordPress vendor pointed it to a bucket, and they changed the configuration, which basically allowed anyone to claim the bucket of this company, and essentially tens of thousands or millions of people just saw my name for a few hours, which scared me a little bit in the night, but it was a good bug, good payout. It was pretty interesting use case of subdomain takeovers. And yes, I hope you enjoyed this one. And let's dive into the 6th use case of this chapter. Hey everyone, excited to show you the 6th use case. And this was a 27.5K bounty. It was in a live hacking event. And it was also a big collaboration with like 4 or 5 people. We found SSRF vulnerability on a major gaming company. So yeah, it was resolved, critical, 27,000 bounty. And I also made a lab for you to experiment and understand what happened here exactly. So in this case, we had a portal, we signed in. It didn't look like this at all, but just the concept. We were given a credentials. And when you are given credentials to a new application, you just want to have your Burp Suite open or Kaido open, trafficking everything in the website, just clicking around. Just click, see everything that is exposed, see if there's any data, anything that might be interesting, and so on. So in this example, while I was clicking across everything and every endpoint and seeing a lot of stuff, I had Burp Suite active scanner running. I won't show this example here because it's a paid feature and I don't even have paid Burp Suite now. But in general, what it did, if you use Burp Suite Premium, or you could also find it yourself, every endpoint that you navigate to in the website, you could have configured it to check for different kind of vulnerabilities, like server-side request forgery, pass traversal, local file inclusion. But in general, what happened here and what I saw here, so I navigated through a lot of endpoints, tried a lot of stuff, and then there was one endpoint which was pretty interesting. So this is a lab. It's not really SSRF here. It's mimicked HTML responses, but just so you understand. So what happened here, when I browsed this main website, in the background, a lot of API requests ran, and there was also this API request that was run over, like API content v2 module 1 version stage files, and then test, like random stuff. What Burp Suite did and the Active Scanner did, for every directory even, not a parameter when you try usually SSRF in like URL parameter, but for every directory, it also tried SSRF payloads. And then it was the middle of the night, we were hacking, like almost going to sleep before the main live hacking event day, and I just went to my Burp Suite and it told me, hey, when I navigated here to localhost, I saw a localhost response. There is an SSRF vulnerability here. So we got pretty excited, and then we tried some more stuff. And the best one to try, like the most impactful one, is the AWS metadata. So if this target is hosted on AWS, you can navigate to the specific internal domain of 169.254, 169.254. Then here you can really fetch the metadata, fetch credentials, and authenticate to the actual AWS of your target. You could view buckets, databases, users, complete control on servers. This vulnerability on SSRFs is very common, this escalation path. You find a server-side request forgery, it means you can send requests in the context of the company you're attacking. This domain is not publicly facing. It's an internal domain only for assets that are hosted on AWS. But when we put it here, the server sends this request, and it not only does that, it's a full read SSRF. So it's not only sending a request there, it also shows you the response. So you can see actually the data, the internal data, and even extract the AWS keys on this target. Essentially what I wanted, the concept I want to give you from this lab, it's pretty straightforward, pretty critical bug, but it's the concept of scanners. It was an active scanner that found it for me because, as I told you, you need to question everything, and there was no chance in the world that I would see this random path and I would try here like localhost and it would work. Like there was no chance. So there are some automated scanners, either in Burp Suite, maybe Kaido will do one soon, maybe some CLI versions that scan you for cross-site scripting, server-side request forgery, and so on. So a lot of scanners that you can use, you can collect all the data, all the endpoints, all the paths that you have once you authenticate, once you get access to an application. And then you need to really look for anomalies or just try, hey, let's challenge this. Let's try an HTTP server here, see if we get interaction. Let's try pass traversal payload here, and so on. It's basically just when you get a new app, navigate in it like a normal user, collect as many API requests and endpoints that you could have found, and then give it to automated scanners, go over it yourself again. But don't just try, once you navigate, hey, there is a search here, let's try access, let's really focus on the search. Give yourself 30 minutes, 1 hour to navigate through everything, collect the API endpoint, so then you could feed it to other scanners as well when you do your manual testing. So in this example, I mean, we didn't need to do anything. The Burp Suite right away found a vulnerability for me, 27.5K bounty, pretty big, pretty impactful bug. Most of the SSRFs, the other examples would be maybe easier. It would be a URL parameter or so on. But it's still the concept of like, never trust anything of a website. Even a path could lead you to an internal network of a big company. So this was the 6th example. It was a very nice event, live hacking event. And I hope you enjoyed it. And let's jump to the next one. Okay, hey everyone, and let's dive into the 7th example of our real-world hacks. And this one was a pretty critical one as well. It was a GitHub authentication bypass on a major CRM company. So the concept of this bug is pretty straightforward and pretty easy. This is the report we sent over email. We found critical exposure, a GitHub token. The token was valid and we could have access over 2,000 internal repositories on their actual GitHub enterprise subdomain. So we had a lot of data here and it all stemmed from one exposed GitHub token. So we sent a report and the answer, they fixed it pretty fast and we worked with them together to remediate the issue. And how we found it was very, very easy, and it's a nice trick that I like to do. And I will show you the example right away. So if you don't know GitHub is the place where most of the companies around the world develop their code, and all the engineers have a GitHub account and they put their code out there. It's very easy to make a mistake and expose secrets on your personal GitHub or from a company GitHub. So usually bug bounty hunters, they look for companies, then they check if they expose any secrets using open source tools. You can check developers of a company and see if they expose any secrets. So you really focus yourself on the secrets of the human element of either the company name, you search for Wiz, for example, or for the developer, you search for my name on GitHub, for instance. I have a small trick that I like to do sometimes, and it's to check based on a subdomain. So for example, here I checked for internal.code.bugbountymasterclass.com. It's very similar to how I found the previous misconfiguration. I took a company root domain, and then I checked for all their internally looking subdomains, like internal, code, and so on. I searched them over GitHub. And then on GitHub, I found like here a .env file with a reference to an internal domain. I mean, this is very interesting. Like, you shouldn't have reference to internal domains on your public GitHub. But I mean, anyway, this is my repository. I expose data here, and there's nothing here, right? But in GitHub, all your history remains, and it's publicly facing. So even if I don't have anything here, but I had a secret before, then it means that the secret is still here, and you can still find it. This is exactly what I found on this major CRM. I saw a reference to an internal domain. Then I checked all the GitHub previous commits, the previous history that was in the repository. And then I found a GitHub token inside it. And using this GitHub token, I was able to actually access their instance and really find a lot of sensitive data and internal code. So let me find the lab that we have here. So github.enterprise. So essentially, I tried to vibe code here like a login page for GitHub Enterprise. Essentially, it was a gated page, sign in with SSO. You couldn't access anything. But thanks to the token I found, this is like just for the flag, but using the token that I found from the single engineer who committed something publicly to his account instead of the company account or internal repository, I could access this GitHub of the company and all of their sensitive data, internal repositories, proprietary source code, and so on. This is an example of a very critical bug. Just you find it on GitHub. You don't need any skills to do it. Just search for specific keywords, search for specific domains, search for specific root domains or companies, then you can find sensitive secrets on GitHub. And similar to the subdomain takeover section, you need to do it at all times. So you might do it one time when you find a company, when you try to target a company for the first time, but then you really want to monitor once a day, once a week, built-in automation that does it once an hour that checks if a company commits a new secret, and you want to be the first one to find it. So this is it, pretty straightforward, finding secrets on GitHub. It's a lot of bug bounty hunters made a lot of money from these techniques, and also myself. So I hope you could add it to your arsenal, and let's jump into the next example. Hey everyone, welcome back, and this time I'll show you how I hacked a major bank in the US using a very common misconfiguration, which is Spring Boot Actuator Heap Dump Exposure. I got paid $4,800 for this misconfiguration, and I'll show you exactly how I found it. It was pretty straightforward and very easy. So this was my bug bounty report, 2024. Hey, this is sensitive actuator heap dump exposed. And this sign, you always want to find this download file, and when you see this, you understand that you probably have a critical bug in your hands. So what happened here exactly? So this bank had a subdomain, and the subdomain just showed, hey, this is a bank management system, version 1, status running. So when I do Reconnaissance and I discover a lot of subdomains of different companies, I always run them for set of nuclei templates, set of exploitation templates that are very common. A lot of companies use them, so I always check for them no matter what. One of these set of templates is for Spring Boot Actuator. A lot of companies are using Actuator for Java applications and to develop a lot of their systems, but it's so easy to misconfigure it that I found it so many examples when company leaked sensitive data from it. So this is the exact command that I'm doing. I'm taking the bank subdomain here, or you could just take a list of subdomains every time you hack a company. I'm using nuclei with the tags of Spring Boot. When I'm running this, I'm really hoping to see two endpoints that are pretty sensitive. Either the actuator heap dump endpoint or the actuator env endpoint. So let's see what will be the results here. Perfect. So in this case, what I actually did, I told nuclei, hey, take this subdomain of the bank, scan it for every Spring Boot actuator template that you know about. So it did find the actuator env, which is interesting, and it's always the first thing that I check. And then here we see some environment variables, but they are all masked, right? We can't really see secret values here. We just see masked variables. So sometimes you could see secrets here. This time it's all redacted, so it's not really interesting. But lucky for us, we have the heap dump endpoint exposed. The heap dump endpoint, essentially what it does, that will let you open it when you do the lab and you can put the certificate. When you download it, you can fetch the data inside it using the cat command or the strings command, and then it shows you all the redacted files here, not unredacted, plain text. Heap dump is basically these machines are doing memory, like they're saving backups, saving their memory, dumps, and they put it publicly facing. That means that you can just fetch it, you download it, then you see all the internal logging of the application. It includes HTTP requests, authentication tokens, a lot of the time AWS secrets, GitHub secrets. This vulnerability is very, 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 very common. It's so easy to misconfigure the Spring Boot actuator heap dump, and I found over $100,000 of bounties probably from this misconfiguration. And the concept here that I want to give you all is basically to check X, check Twitter, check HackerOne activity, check write-ups of many bug bounty hunters for these common misconfigurations like heap dump, .env file exposures, .git config file exposures, and similar ones. And make sure that for every time you scan a new company, check at least for like 10, 20 very common misconfigurations that most likely your target will be vulnerable for. This concept, you can't scan all the nuclei templates because it's 8,000 templates for 1,000 domains with 5 requests each. It's like, it will never end. But you do want to have a quick script that you give a company, and it checks all the most common misconfigurations pretty fast. Spring Boot actuator heap dumps is one of them. You can read about it more. We have a blog in Wiz that we did about it. You can ask ChatGPT or Grok. So you can just fetch more data about this, but really build yourself a list of nuclei templates that you want to run every time for common misconfiguration. So I hope this concept was pretty clear. I mean, I hacked this bank just by running my normal script, got an alert to my Slack, found a lot of sensitive data of their customers, reported, fixed in 1 hour, $5,000 bounty almost. So everyone are happy eventually. So I hope you took some lessons from this one, and let's jump into the last example of this chapter. Okay, hey everyone, so this is the last example for the real world hacks, and I saved a pretty special bug for it. So this was in a live hacking event in Vegas a couple of years ago. It was the last hour of submissions, and we really had no time to find more bugs. And I found a very interesting misconfiguration, which gave me $20,000 bounty, and it was a zero-click account takeover by cookie switching. So I reported a bug with a session confusion. It's a bug you almost never see, and maybe if you hack legacy companies, you might see it, or legacy portals. So I was looking at the company, at the subdomain that we were targeting, and I was able to identify a bug that by being a guest on a staging environment, I could put myself as an admin on the production environment. And I will show you exactly, it was pretty simple what happened, but it's not trivial to try and test for it. It just shows you how you can expand and always try different stuff when you're stuck, or just in general, always challenge the systems, always try new attack vectors. So this was the company. Imagine we had a staging instance to test. Usually when you have bug bounty program or you are participating in an event, companies will give you the staging environment because they don't want you to affect actual production systems. The goal is to find bugs, not to take the company down. So in this instance, we had credentials, and for this vibe-coded lab that I created for you, I just made you continue as guest. So I could log in as a guest to the system. I could do some stuff. I was a guest in a staging environment. Everything is fine. And not only guest, so there was also production environment. So let's go here. So this is the production environment. There is login. I can't log in. You can't log in as guest. It's completely isolated and protected. So I was trying a lot of stuff. I found a lot of bugs here. It was pretty fruitful and successful application for me to test. And in the last hour of the live hacking event in Vegas, I said, okay, let's try like one less ditch efforts to find more stuff. What I did, and I don't know why I thought about it, but it was pretty interesting. I said, okay, this staging instance, this production instance, it looked like systems that were developed a long time ago. It used PHP. It was pretty old. So what I tried to do, I tried to take the cookie, the authentication cookie that I have on the guest instance, and try it on the production instance and see what happens. Maybe it will let me log in even if I don't have a valid user, because you couldn't log into this reseller portal unless you were approved in like a very lengthy process. So just getting access to this instance was pretty unique. So what I did here, I went to the instance, I put a cookie here of the session cookie that I had on the staging instance. Then I tried to log in again. Then I visited the dashboard, and I saw that it actually worked. It logged me in using this guest account from the staging environment. The same cookies worked on production. And not only that, it took the user ID that I had in staging. Let's say I was user 100. And then when I log into production, I was jumped into customer 100. So I took over a random person account, user 100, by using the same cookies from the staging environment. It means that I could create a lot of accounts on staging, take the cookies, put them in production, and hack many users, because essentially it used the same authentication and it took the same ID parameter from the JWT, from the cookie, and it just authenticated me right away to the instance. This bug is not common, but it just shows you how you can find weird bugs sometimes on weird systems. But it was very nice for me to just, like, last hour of the event, like, everyone really want to find one more bug before they are, like, completely dead and, like, exhausted. And I just tried to swap the cookie, and I saw, hey, wait, I'm not familiar with this name that I was just logged into production. And I realized I actually have zero-click account takeover here unfolding. And yeah, this really sums up the course and the real-world examples. And of course, everything that you learned here should help you find your first bug, additional bugs. All the labs here are open, and you could even earn a certificate to find the flags, following along what I showed you here, and the last step you need to do yourself. And yes, this was it. If there are any questions, of course, feel free to reach out, and I had a blast showing these kind of examples, and see you around in the next one.